Good morning. Routing working group will start in 1 minute. If you could please find way to your seats. Good morning again. So that's the start of the RIFE routing working group session. It's me, Ignas Bogdanovich here, and my fellow co-chairs, Jaap Snijders and Paul Hoekstede over here. And actually, for both of them, it's the first.
Hoogsteder.
Hoogsteder.
Right. I really feel corrected by that. Apologies, not an expert in that language. Right. So for both of them, that's the first physical meeting. So please welcome them.
We have done one physical meeting pre-COVID.
A few, yes.
Yeah. The one where we were selected.
Yeah, exactly.
Not, yeah.
Right. So as always, we have quite a few topics to discuss. And at the beginning, the administrative topics, but the clicker doesn't seem to work. Oh, it works now. All right, so the queue etiquette and how to get in line to get questions. Please use the app and use the questions and answers. Don't use chat for raising questions there. Minutes for the previous meeting, they are available in the usual place and as business as usual. One topic that maybe we as a chairs would like to encourage you to look a little bit more. It's from our friends in the Database Requirements Task Force. They have a set of requirements on how they would see the database ecosystem evolving, and some of those requirements are directly related to the routing working group. There's nothing special or nothing really new. It's about general practices of how the things should be done. You have a link there if you are interested in the details. And of course, we as a working group haven't done much tangible work on that. And we as a chairs, we don't believe that this is for us to decide and do that. It's for us to encourage you as a group, if you care and if you are interested, to look into that and comment or maybe try to address those topics. It's not, say, a hard push. It's just a gentle reminder that we have this activity ongoing. And if you are interested and if you care, please take a look at that. And then we have our agenda for today.
Hi, let me talk to you to the agenda. We start with a presentation about Bgp Tools by Ben. Ignas will tell about Bgp Sec. Mikkel will give a presentation about publish in parent. Jaap has got a lot more to tell about debugging Rpki. Alexander will tell us about automatic updating of prefix lists, which is a good idea in my opinion. And then we'll have a lightning talk by Tim.
Right, so then, Ben, welcome on the stage and tell us about the Bgp tools.
Thank you.
My hope is that by the end of Ben's presentation, all of you will set up eBGP sessions towards Ben's project. That is primarily the goal of this talk, to promote that activity. So get ready to configure sessions. Ben, take it away.
Hi everybody, my name is Ben Karakox and this is the unending misery of BGP tools. So Bgp Tools is this. If you've ever used it before, this is the homepage, which it goes and lists immediately what you're connected with, and effectively a search engine. It's not a very refined site on the front page, not much to do other than give you what you're actually looking for. It's designed in order to avoid you from telnetting into things like root views, in order to get data about what the hell is actually going on. And it's also designed to provide a better user interface than some of the things like bgp.he.net, which I have some usability concerns with. So one of the things that I put a lot of effort into is making sure things like mobile support works correctly. One of the reasons of this is because nothing sucks more than being paged in the pub or being woken from a page and someone saying, something's happening in your network. Trying to load one of these sites and finding that you have to pinch to zoom, or like various other annoying JavaScript problems. So the site has a semi-mobile first design while also being functional on the desktop, because that's probably where you're making your BGP changes. And it's also more built in mind with things like modern day problems. So for example, prefixes and ASN lists, so what are your upstreams, what are your peers, are computed on a per prefix level rather than a per network level. A per network level is available, of course, but a lot of the time when you're looking at individually problems with an individual prefix, it's much more handy to know who are the upstreams on that particular prefix, or who more likely in root leaking you in that prefix. The site also tries to help you catch out some gotchas, like for example, the hurricane and cogent split, and we'll put banners where things are obviously potentially broken. I make a lot of effort in making sure that the data is accurate and timely accurate, and so the website will actually publish immediately what its last poll dates for certain pieces of data are with, or alternatively, if the website looks like it's broken, you can quickly go into the features tab and see if most of the BGP sessions are down, which if they are down, the site's going to be a bit broken. And there are some basic APIs if you want to script against it. I generally avoid APIs, and that is because I have commitment issues into maintaining that I don't break APIs into the near future. However, I do provide some things that are very popular asked, things like table dumps, things like who is announcing which prefixes. That's very useful in most scripting. And if you really do feel like you really want to use the website and scrape from it, which I highly discourage, you are more than welcome to scrape the Gopher website, because I really just want to see Gopher support in the internet. Bgp Tools also tries to be slightly more adventurous in terms of data sources than I think normal websites would decide to go for. So for example, in the Internet Exchange tabs, you'll notice there are two more things attached to ASNs on the side. One of them is their detected vendor, and one of them is a tick to indicate that they're online. The vendor detection, that's in the logos, are enabled by my friends pinging various people on Internet exchanges and then dumping their ARP tables to me. Alternatively, I can get them from things like scraping the FE80 linked local addresses out of BGP MRTs, or alternatively just looking at the looking glasses that some IXs like IXBR provide and scraping the FE80 addresses out of those. Online detection is actually much more interesting. IX looking glasses sometimes, so Packet Clearinghouse provides some very good table dumps where you can go and basically just see if a next hop is available. If they are available, they're probably online on the Internet Exchange. Abuse of larger super networks who don't seem to ACL access to IXP ranges, which is a real bonus because while that's actually pretty bad, it's actually very useful for BGP tools. Hence, I won't list you which networks are doing it. The prefix page gives you this neat, cute little Hilbert curve, so that you can see from a glance whether the prefix you're looking at actually has stuff in it, or whether it's things like a CGNAT block that would not necessarily respond to ICMP. Also attempts to give you better view on DNS, so reverse DNS, which is a relatively standard feature, exists in bgp.he.net, but also reverse DNS works on IPv6 too, using some DNS server tweaks or tricks. I also make sure that I go through things like certificate transparency and attempt to go and figure out which domain names are pointing into that prefix. So if you're looking at a prefix that might be from a hosting provider, you can immediately see which websites are pointing inside to that. Handles annoying use cases too, or edge cases. So for example, you have this fantastic VeriSign prefix, which is announced by 22 different ASNs. Most websites kind of implode when you see this because it is not an expected thing to see. There are some other networks that do things slightly differently, like I believe Gandhi announces themselves from one prefix and then upstreams themselves for about 20 or 30 different prefix upstreams. And that's handled as well. So a lot of effort and a lot of my time goes into finding these sort of horrifying prefixes and being like, okay, time to redesign how that actually works. One of the biggest features, I think, is that networks themselves are broken up in different policies. The era of a network having a contiguous backbone and a contiguous announcement policy is kind of gone. Networks these days don't necessarily have a backbone between all their prefixes. Think of something like Cloudflare, who don't have that. I mean, they have some of a backbone, but not every single one of their prefixes is reachable from each other. And so they have independent announcement policies. This is not very useful, though. If you're looking at a wide view of the network, you're going to see 2 million upstreams. In this case, the site automatically computes which prefixes have relatively the same or practically the same announcement paths to tier 1s, and then groups them together into things that you can individually scroll down. It avoids situations exactly like this. How hard, so you may think about it, how hard can this actually be? Surely it's just a bit of PHP or Perl or Python or whatever your choice of poison is. So this is the general data flow, or last week's data flow, and that is, I feel like it's a bit of a cloud diagram, but it's not really that hard. Basically, there are MRT importers, one stuff that basically comes in from Rpris and root views. They go and crunch every 6 hours or 3 hours, depending on the publishing schedule of those root collectors. All that data gets put into Redis. Any data that lives for 24 hours or less generally gets stored into Redis so that I don't hurt my SSDs. And the data is ultimately ephemeral anyway, so why bother storing it permanently to disk? And then practically anything else that has permanence, like for example, Whois or PeeringDB or IIR databases, gets stored in MySQL. And there was some real-time support to try and track new prefixes coming into the table. This way was remarkably cheap to run. So MySQL ran a small amount of storage. Relatively speaking, the only real storage cost was the Whois database, which is its own separate pain point that I'll get to later. And Redis sat around about 4 GB of RAM to consume all of the full tables, which is about, I think it's about 200 full tables inside root views and RIS combined, some of them being the same. And yeah, you can read the slides. The site is actually generally very fast. The page render target is around 200 milliseconds, which I adhere to, I have alerts for. I try to make sure that the site will never generate slow responses where I can. So you may be wondering, what is the absolutely hardest website feature of all of these platforms? And it's definitely not what you'd think. You might think it's some routing analysis or anything like that. No, it's this thing here. It's not Akamai. Akamai is not the problem, although the access denied is. The actual problem is naming ASNs. You may think this is very easy, but this is mind-bogglingly difficult. And I'll give you some quick examples on one of the things that gives me the most misery in my life. This is my ASN's Whois blob, which is slightly truncated. Oh, on the iPad it is, but not on the projector. So it's pretty obvious in this case. The AS name is benjojonet. That's not very useful to display to a user because that's basically what they put in when they first registered the ASN. That might not be true anymore. For example, if you got bought. So instead, it's probably wise to use the organization that Ripe gave you, which is hopefully in sync with reality. That's an easy case. However, you can't apply the organization rule to everyone. So for example, this renders that. Here's a new example. This is a appnik prefix that has been sponsored by someone. Now, appnik's policy says that if you have sponsored someone, the organization is the sponsor. And the AS name, description, etc., gets to be set by the person who is being sponsored. So obviously, if you use the exact same policy on Ripe, on appnik, you will find that every single ASN that has been sponsored obtains the name of their sponsor. That's not very useful. And so instead, you have to yield a bit and allow a appnik-sponsored ASN in particular to be able to set their own AS network. I generally try and avoid doing this because if you let people set their own description for their network, they will generally put the stupidest things on earth in there, like super hyper tier 1 network, or alternatively just dashes because they're actually trying to do some ASCII art, and so the AS name becomes ASCII art. In general, I try as hard as possible to avoid letting users set their own AS names, or at least if they can set their AS names, they must be able to set it using the edit feature of Bgp Tools. This renders that. You occasionally have quite exotic Whois servers. For example, JPNIC has this. which is very unlike almost anything I've ever seen, which makes it creative regexing to find the correct names. This is just attempting to find out what is the correct name you should put to a prefix. The answer is, I guess, KDDI, but it can be very unassuming. And occasionally you just have things like LACNIC, who just give you completely broken Unicode over the whois socket. And actually for a long time, they have recently fixed this. And I don't know if they know they fixed this, but it was actually giving out what I call double Moji bake. And that is, they had corrupted the UTF-8. But in a normal situation, this is recoverable using some careful Unicode rules. Unfortunately, they had then double re-encoded the fact that and making it completely poisonous, which unfortunately means that at the time, there was no way to actually scrape accurate data out of LACNIC. This seems to have recently changed, where being 1 year. LACNIC has some of the strictest whois rate limits that I know of, meaning that it's very hard to keep up with their changes. So eventually, unfortunately, most LACNIC objects look like this inside the website. I try as hard as possible to make sure it doesn't look too corrupt. Falsehoods that programmers believe about whois. This will become a trend. Whois is an incredibly hard thing to deal with because it's basically just dealing with unstructured text and sort of trying to roughly figure out where people's intentions were when they were doing certain things. And before people go and ask, things like RLDP is basically just parsed whois in my eyes. It doesn't really solve the root problem, and that is some of the data quality just is questionable at most. While we're on this topic, falsehoods that programmers believe about BGP. This has also cost me, every one of these bullet points has cost me several hours of my life. I think that perhaps the most nastiest one is that there is only one AS path per route. You may question what that means. Unfortunately, BGP confad, it's very easy if you're writing an MRT parser or any kind of thing that touches BGP. There actually turns out to be 2 AS paths in the BGP message. It's very easy to pick the wrong one and get some really wild data. That cost me probably several days because it was very insidious and only happened on a few peers that like fed through Cisco or something like that. So generally speaking, websites like mine work by importing write-ris and root views. However, these sites are relatively simple. There is a web server, you can download the data from it. They're generally MRT files. However, MRTs themselves, I have grown a small disliking to, in that their format is not exactly consistent, in that there is an RFC, but what different root collectors use sometimes differs. The files are sometimes published inconsistently, or they can become stale without you realizing. Sometimes the actual update times on the files can be recent, but the data was like 2 months old, how? Yeah, I have a big axe to grind against MRT collectors these days, including some MRT collectors don't seem to sort of screen their peers at all, and will actually submit outright false information about their network to you, which kind of poisons your view of the internet. Looking down the graph of BGP, processing is relatively easy until the billion node graph turns up. It's quite annoying. So rather than going down the route of things like HIDA's AS rank, instead BGP Tools cheats a bit and just has a hard-coded list of tier 1 networks. And then all upstreams on the networks are derived by how can someone get to a tier 1. If an AS path intersects a tier 1, then the relationships spanning outwards from that are considered a upstreaming relationship, which is not necessarily true. For example, some people peer with NTT, level 3, etc. It's just easier this way. So for example, this is a set of AS paths. We can assume because 1229 hops by 3170, that because they're between tier 1, that my ASN is being upstreamed by 3170. This was absolutely fine, right up to the point where Sprint and Zayo started accepting routes from root collectors on internet exchanges, and now it looked like everybody had Sprint and Zayo transit. That was particularly annoying. So suddenly, yeah, everybody was connected. Unfortunately, the normal mitigation I would have done here would be to just assume that everybody who has effectively one of the rules, see peer lock, etc., of tier 1 relationships is they probably should never hop more than 2 ASs, or they should, in general, you should be able to see if it's an upstream relationship if it gets handed to another tier 1. Unfortunately, you can't actually enforce this policy too hard because certain networks like Cloudflare have a lot of connectivity to a lot of different tier ones. And if you run this assumption, then all of Cloudflare's upstreaming relationships will disappear, which is not particularly optimal. So instead, some particular handling for Sprint, Zayo, sometimes Hurricane Electric is set where it is required for them to be double hops until they're considered upstreaming relationships. And the awkward truth. So in general, these sites are generally only as good as data as they are provided. MRT files are really quite biased, and I'll get to that a little bit later. All of them have stuck roots. I have lost several days of my life trying to debug weird data, thanks to mostly Brocades sticking roots in their data planes, in their control planes. And debiasing data is a lot of work. You have to be prepared to send out a lot of emails asking networks, is this broken? Is your router broken? What's going on here? And for the most part, people have been very responsive to emails, and I thank you a lot if you've received one of these emails from me. Writing these tools are very easy up to the 90%, and the rest is just awful. The long tail of bugs is extremely long. MRT files are also generally quite biased. So this is a graph showing the amount of unique paths that intersect tier ones. You will notice that Hurricane Electric spans the highest. Most carriers themselves are not very visible. For example, we see AS701 Verizon is barely visible at all in RIS. And if we look at root views, relatively the same story. None of these intersect the full table size, which means that it's very easy. This implies that basically there are MRT, from the standard MRT data sources, it is impossible to find full tables of Verizon and Orange and Sprint, Zayo, etc. Zayo is actually incorrect, you can. But there's a certain exotic tier one that you cannot find full tables of, which unfortunately, if you're doing research on, will bias your data. So what am I doing about this? We built our own collector. If you can't beat them, just simply recreate what they have. Introducing the Bgp Tools root collector. It is frictionless and easy. You do not have to go and email me. Please don't email me unless there's a problem. Instead, you can just log in at the bottom through PeeringDB. It will ask you to set up communication methods. So if you do something wrong or if I do something wrong, I can go and message you through these methods. There's exotic communication methods. For example, I can send you messages through Slack or push notifications through Slack, Discord, Telegram, webhooks, whatever you want, as long as I can reach you. You can instantly create new sessions and bring them up as soon as possible. There's no time, there's no propagation delay, and you can see the status of every single session on the back end in real time. This is the form that you will fill out in order to create, hopefully you will fill out, in order to create a new BGP session. It's very basic. When you submit this page, capacity search goes and fans out and tries to find a root collector that has memory capacity for your session, and it will give you that there. And once it gives you that IP, it's literally good to go. I would highly recommend you go and set one up. When you go and set one up, it will go and ask you these 3 questions. So the first one is, do you want to export data outside of Bgp Tools? So if you want to go and give to the academic community this data, entirely up to you. The second one is whether you want those MRT files to be split out into a separate pool that can be used for commercial products. I feel like this is quite an important distinction because I feel like some of the reasons that people don't want to feed these tools is because commercial tools go and use them as well. So you get to choose. And the third one is whether you want me to nag you if your session goes down. In order to pull this off, I wrote a custom BGP daemon that was specifically designed for root collection. Does a couple of quite nice things. For example, forking every session into an individual process so they can crash independently, but also that they generally coexist. There is nothing worse than dealing with the 64 gig to 128 gig mega process. In this case, you can go and kill sessions off or slowly roll them without having too much misery in operational. It makes a massive difference. The data quality has already improved despite only having around 80 sessions. Much better visibility of certain tier ones, especially things like Zayo and Verizon. So thank you to the people who are already feeding me or people who have sent emails asking for sessions and you've actually built them up. Fantastic, you've helped me a lot. Unfortunately, that was a GIF, but I didn't realize that we were using PDFs for this. So unfortunately, you just don't need to see that. Basically, if you keep prefixes open in real time and make quality changes, the actual website will update without refreshing. So you can actually use this to plan maintenance or anything you're doing, like dropping a carrier, you can go and watch this change in the global internet. I won't go into this too much, but effectively, this is what Bgp Tools looks like these days, and that is set of BGP sessions, now feed it rather than Redis. And if you like this tool, I'm particularly looking for these carriers. If you have these tables, please go and either talk to me afterwards or just set up sessions, and I'll be highly appreciated. Also, if you just want better peering numbers, because who doesn't want a slightly more attractive looking network, you should feed anyway. Also, obviously, helping the academic community. Questions, requests, etc.
David Lamparter. Have you considered ingesting BMP streams?
Yeah. So BMP streams I find difficult to use because it's very hard to go and track. It's very hard to track when BMP streams disconnect. I may be stupid in this situation, and I just don't understand BMP tools, BMP streams correctly.
No,
But I always fear, for example, if I miss a session drop notification, then effectively every single route from there on is stale, and I will have no idea, which to me sounds like a catastrophic failure.
It's a known issue.
Yeah, this to me is like beyond catastrophic, because in which case everything from there on is stale.
Robert Kestaki, Rpki. I applaud you for the amount of information you conveyed in the amount of time you had, and also the stenographers for keeping up with you. The question of naming ASNs came up many times before. Would you say that there would be a point in making some kind of a crowdsourced database that actually has useful AS names?
Bgp Tools has an
I heard one, yes.
Someone earlier today suggested, asked about effectively an API, which I happen to also have API behind the sofa for dumping ASN information, ASN naming information right out of Bgp Tools. I didn't realize that there was so much of a demand for this. I will happily make this API open source. It basically just dumps you a CSV of what I think everyone's name is. And generally speaking, I go through this list and make sure it's accurate.
I think what you think the correct name is useful, but with people, the crowd can help you in there. That's probably even more useful.
Yes, and there's an edit function on every single AS page. If you think that something is obviously false or obviously wrong, then you can submit an edit to.
That's great. Thank you.
Suggest it.
David Schweitzer, I work for NetDev. I have a question regarding the data retention. So you mentioned you have like 13 gigabytes of data. So we have a similar database. It's the AG. We have 77 terabytes. Mm-hmm. So my question is, how long do you retain your data on updates in your database?
I don't put updates into the database at all. For right now, and until I start actually exporting MRT files out publicly, basically no data is retained. If an update comes in, that just goes and alters the table, and the previous data is thrown away. This is probably going to change in the coming months when I purchase hard drives to store this. But right now, I don't have the storage capacity to tank that.
Okay, well, plan ahead and get a lot of storage capacity.
Yes.
Right. We have one question from the online attendee. That's Anton Verschuren. Have you considered investigated using RDAP instead of voice where available?
What was the thing instead?
RDAP.
RRDP?
Yes, RRDP.
Yeah, so I briefly touched on this.
I think it's RDAP. RDAP.
Oh, okay, sorry.
Assume, because RDP is a different thing.
Okay, sorry. Yeah, so I've looked at that effectively, and once again, I may be wrong, I may be misunderstanding things, but it effectively looked like doing the job of just parsing out the whois into JSON fields, which isn't always what I necessarily am looking for. I can parse the text whois fields. It's about knowing contextually which whois field to pick the data from correctly per RAR, per sub-RAR. Hi.
Hi. Rüdiger, sorry, no question. Kind of flashback into history. I tried to get the schema of the SRI NIC in '89, and I was told, well, okay, we can't hand it out. And anyway, it's based on ancient software running on 36 computers, which were still around at the time, but well, okay, destined for death anyway. Unfortunately, as we managed to get something like RIRs out, the question of coming up with a common defined schema actually didn't happen, because the Americans stayed with the old stuff, the Europeans did something nice, which actually got standardized in our as RPSL, essentially. But kind of APNIC broke some rules. LACNIC invented its own thing, looking like the RIPE stuff, but definitely a completely different schema. And the IETF work to kind of recover from this is essentially ending in RDEP, which is providing common access protocol for a coordinated schema. So kind of saying, well, okay, the presentation layer that you see, you find annoying. Yes, I would prefer XML. Please throw X. But kind of the presentation layer really is not the interesting thing. The interesting thing is first have a clear schema idea and then work with the presentation layers, and the RDAP there is the right direction to orient.
Thank you.
We got a question online from Mike Marshall asking, what's the link for setting up a BGP feed?
It's PRND, it's brain. It is bgp.tools / just go to Bgp Tools and scroll to the bottom, and there's a button called Contribute Data. Click that, and it'll tell you, it'll be a brief page that tells you what you're getting into, and then there's a login with PRNDB button. If you cannot log in with PRNDB, send me an email and I'll sort it out.
Thanks for your presentation.
Thank you.
Hello again. Let's discuss a little bit about Bgp Sec. So all of you are well aware that Bgp Sec is just evil. It doesn't exist, it doesn't work. If it works, it's too slow. If you want to deploy that, you need to replace all your new shiny kit because it has large resource requirements. You might also argue that origin validation is more than enough for securing the routing system. There are also other options available for path validation. It just doesn't scale. It may leak things which you don't want others to see. Maybe it's just a nice academic experiment but doesn't address the real problem. And dealing with the keys is always complex. It involves hardcore cryptography, and well, BGP is secure anyway. Why do we need to do anything else? So that's quite a lot of negativity. Let's focus on a couple of those areas and look deeper into them. It's about the performance of Bgp Sec. A trivial reminder of what Bgp Sec is, that's a path validation solution which cryptographically signs the elements of AS path and also forward signs to whom we are advertising the prefix. This way we get a cryptographically verifiable chain that can basically give you an answer that this path is really valid or it's not valid. Each individual prefix is signed separately, and that is one of the contributing factors to the complexity. I really thank you for putting the light straight into my eyes. Now I cannot even read my own slides. Let's do some experiments and see how it operates in close to realistic world environment. Modeling an operation in as a route server in an exchange of a moderate size, take the available publicly available feeds of data, slice that, get the realistic distributions of paths, prefix to path ratios, path length distributions, and things like that. The total setup is 450 full view feeds. Bgp Sec is pre-computed on the feeder node. All the cryptography, all the heavy operations are done in advance ahead of time for a simple reason. For example, generating several hundred of millions of random numbers, of cryptographically strong random numbers, is not a trivial task to do. And then that is all fed into the device under the test, and the measurement is for the total convergence time, first prefix in, last prefix out. Bgp Sec verification is done before the best path selection. Therefore, we are testing the performance of Bgp Sec operation, all feasible paths, not just the best one. And also you try to use caching of various types and sorts where available and where feasible. Now, the results themselves, they are relative, they are not absolute. They just show the ratio of plain BGP versus a specific implementation of Bgp Sec tested in a specific environment. That should not be seen as an absolute source of truth. What is important is the difference in convergence time. So that difference in convergence time is quite noticeable. If something takes around a minute and a half, if we redo exactly the same experiment with Bgp Sec, it takes over half an hour. Now, you can argue that in a realistic network design, you will have multiple route servers or other BGP central nodes, and taking one out of service for half an hour is probably doable. However, those numbers seem to be a little bit off, and let's look deeper of what is causing that. Is that a protocol at fault, or is there something else? Oh, stepping back into an area of a general compute platform analysis. If we look at the contemporary platforms today and for the last decade, they have more than enough of the raw compute capacity. So in a sense, the processor speed is not a limiting factor. There's definitely more than needed. The limiting factor is memory bandwidth and memory latency as such, and that is not getting better. The following generations of memory systems, they basically operate at the same speed. So the capacitor array operational speed is mostly the same. What is increasing is the interface bandwidth, but that can only be used if you are able to sustain multiple, and multiple, I mean multiple hundreds of active memory operations. Otherwise, you are just getting bit by the memory latency cost. If we are looking at the scalar compute platform performance increase, that is single-digit % generation to generation at best. The major increase in compute platform performance is in vectorization, basically having operations which operate on wide or on multiple parallel sets of data. And if you want to use the compute platform to a full potential, that is the only practical way. Caching and all sorts of batching approaches, doing multiple operations in one instance of time is normal software engineering practice. However, what is important that your protocol mechanics and data structures need to be friendly to that. If today you write an implementation that is not friendly to the underlying hardware, you should not expect to get reasonable performance. Looking into details of how Bgp Sec operates on the wire. On the receive side, we receive the signed path. That's a rather long message by the BGP standards. Today it's 100 bytes per ASPAV hop. We don't sign that message and verify that message directly. We take a hash out of that message, get a much smaller fixed length value, and then sign the value of that hash or validate it. Hashing is computationally not that expensive operation, but it touches memory, and touching memory is expensive. For signatures, the current specification of Bgp Sec uses elliptic curves, the wire truss elliptic curves, prime 256 specification in particular. And that is noticeably compute-intensive operation. That includes, well, it includes trivial operations, but on the long integers, 256 bits and above. And the good thing about that, it doesn't touch memory. Therefore, you are limited only by the capabilities of your compute platform. Both of those operations can be vectorized, provided that memory accesses do not interfere with your platform operation. And also the protocol allows for that. How the parallelized operation of signature validation can look like. In order to validate the Bgp Sec path, you need to do validation for each hop recursively. So that means starting from the longest path, you recursively continue until the origin. Operations which are performed are exactly the same. You calculate the hash, but on a different data. Then you have a set of hashes, then you perform elliptic curve validation procedure with different keys. This is an ideal fit for vectorized processing. However, not everything is so fine. The wire format of Bgp Sec is just directly opposing to our requirements for efficient vectorization. That 100 bytes per hop is spread around in multiple places in the message in fragments which are not multiples of 4 and 6. And if you want to use the efficiency that the hardware platform provides you, your granularity needs to be 4 or 8. Moreover, SHA-2 hash function also requires that the minimum elements on which it operates is 4 bytes. Therefore, in order to use the efficiency of the platform, first we need to copy memory back and forth, again, paying the cost of memory bandwidth, then doing our actual work. And then, because the wire format is not in our compute format, we need to copy that data back again, only to send it out. So we end up paying memory latency cost multiple times. About the transmit side, Bgp Sec signs next hop AS number together with prefix. The hash is taken from the whole constructed message, and that is signed. This part is simple. What is not so simple is the actual location of the target AS path. And that's in the very beginning of the message to be hashed. That means that if we, in this particular experiment context, have 450 outgoing neighbors, we will have to rehash exactly same message, which differs only in the first 4 octets 450 times. If we move the location of the target AS to the back, we can calculate the hash once, cache its value. It's a block hash function, increments in 64 bytes. That's just trivially cacheable. And the overall cost becomes only recalculating the last patch, which will be different anyway, because you have different target AS and different prefix. And again, this operation can be vectorized efficiently if data layout allows for that. So with these experimental fixes and changes to the protocol layout and its image on the wire, we can get, without too much effort, an order of magnitude of performance increase. That is not Bgp Sec as you have today. Does that mean that Bgp Sec is completely broken? No, it's not completely broken. The biggest problem is that the way how protocol is specified today, it is suboptimal and openly unfriendly to the contemporary compute platforms. And going forward, that is not going to change. Memory cost and memory latency will just increase, and we will have far more plain raw compute capacity. Therefore, what can we do about this? The current specification of Bgp Sec allows for some flexibility. It's versioned. It allows you to define different subfields over there, and therefore we also have certain advances in the cryptographical industry and in general. algorithm applicability of advances in the crypto systems. There are Edwards curve elliptic cryptography systems which are far more performant than what is currently used in Bgp Sec, due to the reason of the prime field that on which we are based being much closer to the binary numbering. And certainly all of the WebPKI and TLS ecosystem cannot be wrong using that universally as a default algorithm. So that needs to be taken into account. There are other more performant or more suitable for this use case hash functions than SHA-2. And also the wire format needs to be rearranged. So this is clearly a work in scope for the IETF to do, and that work is trying to progress, or slowly trying to progress over here. So some open questions about the overall scope and feasibility of this. Can we avoid all of that by just putting some secret switch to favorite compiler and it will take care and do that automatically? No, it cannot. We are talking first thing about the wire image, the layout on the wire, and that requires protocol changes. We are talking about beyond trivial layout of data structures. Compilers for auto-vectorization, yes, they can do that, and they certainly are good at trying to cover certain rather routine tasks. But at this scope and at this coverage, magic compiler switch just will not help you. What if I rewrite my BGP implementation in whatever programming language is fashionable today? Well, you will get mostly the same, if not worse. That's not a problem of language selection. That's a problem of the data structure layout. Well, availability of vectorization is universal. The laptop that you are typing your emails on with a very high probability has a reasonably usable form of vectorization. And in particular, we are talking about x86 platforms. So AVX2 has been universally available since 2011, AVX 512 since 2015. You just need to use that, and you need to use that specifically. It's not something that you get the benefit by default silently. Memory system evolution will certainly continue, but you cannot run against the laws of physics. The speed of the capacitor array, which is the center of the memory system, is mostly constant. What is increasing is the width and the speed of the interface into that capacitor array. And yes, if you can sustain multiple operations, you will benefit from that. If you have your scalar code, which tends to deal with memory accesses scattered around, you will still continue to pay the price, and that price is increasing. The newer generations of memory overall are slower for this type of usage than the previous ones. Therefore, Bgp Sec can be made reasonably performant. Yes, you need to make some tweaks to the protocol. And now, given that Bgp Sec version 0, which is the current specification, has 0% worldwide domination in deployment, that doesn't seem to be too backwards breaking a change. The other aspect is that majority of the contemporary hardware, both specialized network kit and generalized compute platforms, they have more than enough capacity, and they have plenty of means for using what we need here. Now, is the crypto, there are dedicated, say, extensions for crypto acceleration. Vectorization of various flavors. There are also advances in plain software engineering where you can get benefit out of using your platform. Therefore, it's not true that Bgp Sec as such requires a change in your hardware. Well, of course, if you have the aging platform, you might have good reasons to replace that, not only of Bgp Sec. So, with this, we addressed a couple of the problems with the Bgp Sec. Of course, there's still a large list of remaining items. This doesn't mean that doing only this will magically allow for the global Bgp Sec deployment end-to-end tomorrow. No, that is not going to happen. We still have a long way to go. Therefore, we are taking this step by step at a time and addressing one problem after the other. And that is basically end of my story here. Any questions, comments, or radical disagreements?
Testing. Yep. Before people jump to the queue, we have time for one question, and I'm going to pick it from the Q&A. Kurt Kaiser asks, would an overhaul of Bgp Sec ideally replace Rpki? I understand the implementation needs to be within the routers rather than parallel to the net as with Rpki.
Well, Rpki is orthogonal to Bgp Sec as such. Bgp Sec is the wire protocol. Rudiger, you have a comment or you want?
Sorry,
Yes.
I'm going to do strict queue management.
Yeah.
We have no time.
There is one basic false statement, Ignas, that you did. You said BGP Sec is AS path policy. That's wrong.
Did I say that?
Well,
No.
okay. I think I missed the exact word, but you said it is path stuff, and you missed the essential thing. BGP Sec is authenticity of a key BGP attribute. Before BGP Sec, everything in BGP is not authenticated, is not sure to be the truth. And BGP Sec does that for the path attribute, and that gives us the possibility to make sane decisions about how we use the route, because we know this is true. And the Rpki is a cryptography system that is the basis for actually doing that. So the question is kind of
Rudiger?
showing basic misunderstandings that are very far around.
Those things are orthogonal. One is a protocol, another is a database, right? And in order to get something, you have to have both of them. One relies on the other. BGP Sec is not a replacement for Rpki. BGP Sec can be used for other attributes if you wish. There's nothing in protocol precluding that. Just that it's not specified today. And I think we need to look into that, but that's completely separate topic.
Rudiger, it is rude to jump to queue ahead of other people. Don't do it again.
I was first there.
We are chairing this session. We can through Q&A first. You don't get to decide this. We're out of time on this topic. Sorry, Tom. The next presentation is Mikael from Rpki, who will tell us about a project they've been working on recently called Publish in Parent. Mikael, thank you for being here. I look forward to your presentation.
Thank you. Okay, how do I switch this? Okay, so it's going to be a relatively short talk, essentially an update on what we're busy with regards to this topic. Slightly clumsy name, Rpki publication in parent. So how do I switch? The green button. Yes. Okay, so what is it about? It is about essentially the model that you can have for the certification authority when you create the Rpki setup. And of course, there's two choices of doing this: a hosted CA or delegated CA, which is pretty much supported by every RER nowadays. As you can see in this big cartoonish pluses and minuses, there's obvious pros and cons to both models. For the hosted one, it's actually very easy. Let's say for simplicity, let's say for the Rpki version, that is basically clicking around in the UI just for a little bit. And from this moment on, we, Rpncc, will create the objects, update the objects, rotate them, make sure that they don't expire, and so on and so forth. But we also store your private keys in this case. So that requires some extra trust. And for people who are not really okay with that, there's a delegated CA version of that. And but the downside of it is that essentially everything, all the objects, all the certificates, RAWs, manifests, CRLs, whatnot, is supposed to be maintained by the software running on the premise of the child CA, LER, end user, whoever. So that is obviously requiring more work and effort to maintain. So here comes in the publication and parent thing. Essentially, it's a service for delegated CAs. You probably have heard about it before, called Hybrid Rpki or Publish and Parent from APNIC. I think historically APNIC was the first one to introduce that, maybe 2 or 3 years ago, even more probably. It's also now working in Erin for about half a year or so. So we are not the innovators in that sense, in this area at least. So essentially delegated CA does create all the objects and does maintain them and rotate and all that, but it sends them to the parent CA, in this case Rpncc. There's a RFC 8181 or publication protocol, in other words, which is used for that. So that's a tiny bit that essentially makes it not necessary to run your own repository, which may be sort of probably the most time and effort consuming part of running your own delegated CA. So we as a parent CA will basically keep the repository for you. So what's the point of it? Why would you want to do that? So first of all, it's has a relatively good availability. So let's say our RDP RipeNet repository is pretty nicely available. Let's say I'm not gonna punch myself in the chest and say it's 100%, but it's pretty good. It's also backed up, well, cached by 2 CDNs at the moment, so it can hold really high loads. It can absorb pretty serious traffic spikes. So things like changing of, let's say, a session ID in RDP protocol, which usually results in very high traffic, is actually not a problem. And the other probably even more important thing that I already mentioned is that having a delegated CA doesn't mean you have to maintain your own repository, make it available, make it, I don't know, set up the rsync, set up HTTPS, all the thing together. And that seems to be a thing for quite a lot of current CAs, because from 25 plus or so delegated repositories that we have under our trust anchor, at least 1, 2, 3 is usually not available, having things expired, having things broken, our sync is not set up, something like that. So people do tend to kind of, I don't know, set up an experiment and then forget about it, or just forget about it, I don't know. So that does happen, and this thing would really help. Yeah, so from the technical point of view, so the minimal viable product that we are working on now, so I'm not reporting like the finished thing. It's a work in progress. So this work is based on Creel software as a publication server. We're essentially not expecting very high number of such delegated CAs, because at the moment of making this slide, Apenic had 4 clients and Erin plus or probably more. Anyway, it's like below 10 in any case. So we don't expect a very high churn of data, objects, whatnot. So the redundancy setup that we are going for at the moment is essentially some sort of primary standby instances of Krill. So there's no big fancy cluster-based solution at the moment because it probably doesn't make sense. But of course, if that feature has serious uptake, which it may happen in principle, because at least in theory, that sounds like quite a useful thing to have. Then, of course, we will have to change the implementation to something more suitable for, let's say, higher churn of data. Yeah, so the status of this work is essentially, it's being our main focus at the moment for the last probably couple of months. There's a lot of sort of infrastructural work, thinking and rethinking, and it's been probably already 3rd version of the same thing that we kind of had to throw away the previous 2 versions and work again. The production launch is planned for Q2, which means we have probably 6-7 weeks left to do that. And we would like to have people who participate in testing of this stuff. Yeah, because we definitely need someone to tell us that we're doing something terribly wrong, if we do. So if you want to be included in this sort of trial, yeah, drop us an email. There's a Discord channel, everything. So that would be nice to have people who would try this thing on production. Yeah, that was it. If you have any questions, please go ahead.
Hi, Blake with Zayo. Thanks for this. Sorry, did you have anybody in the virtual queue? I guess not.
Myself.
Okay. Thanks for putting this together. Do you have an idea of what scale we're talking about before you need to reevaluate, like hundreds, thousands, 10,000 in terms of CAs on the NCC platform?
So for the ones that are hosted, we have at the moment, I believe, 20,000 of them.
Right.
For the delegated, it's tens. So, I mean, tens of the repositories that are actually running and doing something, because I believe that there's much more of them in our database, but they're not doing anything. So it's below 30 or so.
Right. So how far do you think that can go before you need to reevaluate? Because you're at like 30 right now.
I guess it's not just the number of CAs, it's more like the amount of queries.
It's the amount of data.
Yeah, so it's probably not the amount of data. We don't expect a lot of data, but we may expect a lot of requests. Yeah, just them basically knocking our doors all the time. And if we have to be more sort of real time and have multiple instances running and zero downtime setup of some sort, so that may be an issue.
Thanks.
Tim Ruijsels, Anonymous Labs. I code Krill. Data point, in Brazil, they're using this model effectively for well over 1,000 delegated CAs. So I think that proves that running your own CA while publishing at your parent is relatively easy to do. With regards to the availability, this is the availability of CAs to publish. That's independent from the availability of the data for relying parties. It's important to realize. And well, I'll leave it at that for now.
Yeah, that's what basically I meant by availability of the repository for the rest of the world. Yeah.
Job Snyders, Rpki enthusiast. Not a question for you, but an address to the group. I believe publish in parents is the best current practice when it becomes available as a production service. Imagine that there are 10,000 CAs and your Rpki validator needs to connect to 10,000 separate endpoints. This has scalability issues for the whole ecosystem. So sending your data upwards to RIPE reduces the number of connections each validator needs to make, improving performance for everybody. So it's not just, it's hard to host your own publication point, but you're literally doing everybody a favor by using RIPE's publication service instead of running your own. So use publish and parent, and Tim, thanks for coding support in Krill.
Thank you.
Thank you. All right, thanks a lot for presenting this, and then
okay. And next up is Job with this presentation about debugging Rpki.
All right. We are running over time. I already feel bad. My name is Job Snijders. I work for Fastly and I code on the Openbsd project. And as part of the Openbsd project, an operating system that tries to integrate cryptography as far as they can, we also run and develop a Rpki validator. And in this particular presentation, I want to teach you some things about the Rpki data structures and how you can look at that from a command line perspective. So this is not like how do you set up RTR in your network and do origin validation. This is trying to zoom in on the underlying files and structures. In this presentation, we'll go over what a signed object is, a little bit of an overview of various types of objects that exist, how exploring and validation at a high level works, and some remarks about timers. Now, what is an Rpki object? It's super simple. You download an object and you can use the Unix cat file to look at DER encoded garbage. And if you cannot read this without external tooling, you have some more studying to do. This is a huge departure from, say, IRR-based data or even RDAP data, because we're, I think, generally somewhat used as network operators that we could look at the data and have it be presented to us in a somewhat human-readable format, which greatly speeds up our debugging abilities. But with Rpki, we lost that ability, and that means that ability needs to be supplemented by other tooling. And that tooling is now somewhat reaching a level of maturity that it's usable for the wider public. So what is a signed object? A signed object is a binary blob, and it follows a serialization format that stems from ASN1. And each blob is identifiable by its hash, a SHA-256 hash. Each signed object is non-malleable. That means that there is only one way to binary encode a specific object, and that means that a unique hash exists for each object, and there's a strong one-to-one mapping between the two. And why this is important, we'll get into later. Signed objects are encoded according to the cryptographic message syntax, CMS. This is an IETF standard to facilitate cryptographic operations and to put data in a specific canonicalized way into a structure, which then lends itself for signing. You can think of CMS as sort of an envelope, and that on the outside of the envelope, you have a signature and a hash about the contents of the envelope. And this allows a validator to layer by layer peel back, jumping towards the actual substance of the signed object in a safe and secure manner. What is in the envelope is mainly two things: the so-called E-content or encapsulated content, and this is the meat of it. So in the case of a ROA, this is the origin ASN and one or more prefixes. Also inside the CMS envelope is a X509 EE certificate. This X509 certificate contains various pointers to other objects in the Rpki that you use to create a chain of a validation chain and some hash and signature stuff. You can think of the Rpki as a sort of pyramid where you go from root to edge. The root is a so-called trust anchor. You find this trust anchor using a TAL file, trust anchor locator. There are intermediate nodes in this graph, the certificate authorities, and at the far edges or leaves, you have signed objects such as ROAs, GBRs, CRLs, whatnot. You can trust those objects through a mechanism called Derived Trust. So the trust you put into the trust anchor is assumed trust. You choose to trust the right trust anchor, and from there it logically flows, or you derive trust in relation to, say, ROAs or Bgp Sec certificates. You download the TAL. This is usually a one-time operation. That TAL contains a reference to the trust anchor certificate. This is a self-signed certificate. You download the trust anchor certificate. This contains a thing called the subject information access. And this basically is a pointer to the manifest. You download the manifest. The manifest is a listing of files, which could be other certificates, at least a CRL, and ROAs or GBRs or future signed objects. You then in turn download each file. You can verify that you downloaded the correct file by comparing the hash of what you downloaded with the hash listed on the manifest. And if one of those files that you downloaded because it was listed on the manifest was a CA certificate, this repeats. And of course, in reality, validators do lots of optimizations and download stuff in bulk and go through it very efficiently. But in concept, these steps are what happens for each certificate, then manifest, and then subsequent objects. So I made a beautiful drawing this very morning. I'm going to put it up as NFT. So at the top, we have a certificate. This is like a pattern that repeats throughout the Rpki chain. So I took, say, a molecule that is repeated over and over in the data structure. You have a certificate which has a SKI. This is the subject key identifier. And a way to think of this field is that it's the self. It is that value that identifies that particular certificate authority. So SKI stands for self. It's the identifier of the thing itself. It also has an AKI, which is the authority key identifier, and that is a pointer to its parent. It points to the SKI of the parent. So every AKI points to an SKI. And it's these pairings that create the validation chain. A certificate, a CA certificate contains a reference to a manifest. This is in the subject information access. Let me see. So this thing points to the parent. This is the self-identifier. The manifest points to a signed object called a manifest, which also contains an SKI. The manifest contains a reference to its parent, the certificate, and a listing of files. In this listing of files, there's a reference to the CRL. The CRL identifies who its parent is, so we go back up to the SKI of the CA, and a list of revoked certificates. The manifest, for instance, lists a ROA, so we go that way for discoverability. The ROA points to who its parent is, again the AKI, that is the CA. The ROA itself has an identifier, the SKI. The ROA references what CRL should be checked to confirm that the EE certificate of the ROA is not revoked. And then there is the e-content, the origin ASN, and the list of one or more prefixes that this ROA contains. There's more links, more validation steps, but that would never fit on this slide. But there's lots of links, linkages inside Rpki objects towards each other. Now, how can we actually look at this stuff? There's multiple validators, but for this particular presentation, we're going to look at Openbsd Rpki client, which I like to think of as the TCP dump of the Rpki. Installing it on Debian Unstable is easy. You install Debian Unstable, type in apt-get install Rpki client, you start the thing, you wait a little bit, and then you can jump into the cache directory. The cache directory contains Rpki client uses the file system as its database. If you compare this to, for instance, the Rpki.net implementation from Rob Austin and Randy Bush, there the backend was a SQL database, and there's various models to store Rpki data. This particular implementation uses the file system itself, which makes use of tools like find and grep and whatnot much easier. Inside the cache directory, you see a list of directories. Each one of those represents a publication point. And what I mentioned in my earlier comment towards publish in parent, we as community have to keep this cache directory as small as possible, because if we have thousands of repositories, that means thousands of connections for each validator, and that has poor scaling capabilities. But on the other hand, it's really interesting to dive into the repositories and inspect people's individual objects. So you can see Aaron's repositories, for instance, here. You can just change directory into it. NLnet Labs, Chloe.sobernos.net is myself. Rpki.ripe.net is by far the largest one. An Rpki client will remove all invalid objects from this cache directory. So when you're navigating this directory, you're looking at the current valid state of the Rpki global database. You can use Rpki in so-called file mode. Am I pronouncing it right, Ben? File mode is activated with the -F command line option, and then you provide as argument a file that is assigned object. So in this case, we provide it with a manifest as input, and then this Rpki client utility will decode the DER CMS structure inside that file, that binary garbage from my second slide, and display in human readable format what the contents of the object are. The hash identifier is the SHA-256 hash of this file. And why that is important, we'll get to. Subject key identifier, or otherwise self-reference, the authority key identifier, serial, where you can download the authority, what version or what number of the manifest, higher is better. Manifests can only go forward, there cannot be a decrement. The validity window of the manifest, so if you are before this date or after this date, the validation line will say failed, and then the listing itself. And for each file, it lists the SHA-256 hash that should be the results when you compute the hash of that particular file. If we look at a CRL, again, you just use file mode. The CRL has a hash identifier, and that could, for instance, be listed on the manifest, and this is how you can link a particular file to a particular manifest. The CRL contains a list of the serial numbers of the certificates that were revoked, and each invocation of this utility shows the certificate serial if applicable. CRLs also have a validity window, and if you're outside that validity window, the CRL is not usable. There's an interesting type of object that is not widely used at this point in time, but I think has many benefits when troubleshooting Rpki related data. This is called a GBR, a Ghostbuster record. And this is like dropping a business card in your repository in case you run into some kind of issue with the Rpki data itself. You then can, you know who to reach out to discuss what is going on with a particular set of Rpki data. Like any signed object, the Ghostbuster record or Rpki business card has a reference to itself, the key it was signed with, and its parent, the authority key identifier. We can also look at a ROA. Again, same invocation, you just use file mode. It will print the aspects that are common between all signed objects. This means you can find its parent or find the URI of the parent. And in purple, you see the E content. So you can see the AS that is authorized to originate one or more prefixes and the max length of each prefix. And the validation OK part means that the signature chain all the way up to the Derived Trust anchor is correct, and that none of the intermediate certificates have been revoked through a CRL, and that none of the CRLs have expired. And if you are writing a Rpki CA implementation or running your own publication points, you can use this utility to confirm that your objects are in fact valid. And then finally, since somebody claimed that there is no Bgp Sec deployment, I am the only person on the planet publishing Bgp Sec keys, and this is what a Bgp Sec key looks like. It is a signed object, so it has the SKI, the AKI, a pointer to where you can find the parent, and then finally a subject public key information string encoded in base 64, which is the public ECDSA component that you can use to verify BGP announcements I sent to you signed with the private key associated with this public key. And the AS number this public key is associated with. Now, what is very, very different from IR compared to Rpki is that the Rpki is full of timers. Every signed object has a EE certificate which has a not before and not after date. Every certificate authority has a not before, not after. Every CRL associated with a particular CA has a so-called don't use it before this date, don't use it after this date. The manifest E content, as you saw a few slides earlier, has a window in which it's valid. And validators will look at the transitive expiration moments. So they look at all the dates on which various things could expire. And the one that is soonest is the one that ultimately triggers whether an object is valid or not. And this is a completely different world from the IR, especially in third-party databases that don't require a recurring payment, where objects will be around forever and ever and ever until the heat death of the universe. I think the Rpki mechanism is superior in this regard because the existence of expiration timers forces cleanup to a degree, either because people took their publication point offline, and then the the expiration dates will trigger evaporation of this data in local caches elsewhere. Or for instance, if contracts expire with the RER service. All in all, expiration dates are good. I like to think of it as the expiration date on a carton box of milk. That date is very useful when you want to decide whether you want to drink that milk or not. Other ways through which objects could be considered invalid is if adjacent objects are missing. A few slides back, we saw the manifest listing. How the system works is that a manifest, there we go. A manifest is a very robust grouping of a set of objects. The manifest tells you these objects belong together, and that means that if one of those objects is missing, which could, for instance, happen if the file is corrupted, which means that the file and the listed hash do not match with each other, or if this file, for instance, is just entirely missing, that all of the files are considered invalid. And the advantage is that if you have a specific ROA configuration where you, for instance, combine ROAs that contain some supernets and separate ROAs that contain more specifics, that you can tell to the rest of the ecosystem, either use these files together, exactly as I intended them to be used together, or don't consider them at all. And this bundling of files, the ability to communicate to validators, these belong together, is a feature we do not have in the IR, but I think is a fantastic feature in the Rpki. So that's how things could be invalid. Now, if you don't want to play with binary encoded files, I have a JSON dump that is 130 megabytes that you can download that contains a JSON decoding of the entire current global Rpki database. And this is fun to pull through a visualization process or use a monitoring software. And with that, I've gone 90 seconds over. My apologies to my fellow chairs. If you have questions, you can either, if there is time, ask them now or email me.
So please contact Job via contacts. There is one question in the virtual clue, but apologies, we don't have time to answer that. Job will take that into account and respond. And we have to move to our next presentation.
Thank you.
Thank you, Job. Right, Alexander, the stage is yours, and tell us something about automatic updating of prefix lists.
Hello, my name is Alexander Zubkov. I work at Curator Labs, and we know about the importance of filtering of routing information, and there are many articles about it, and you can find examples of how to use tools like BGPQ or RR toolset to generate prefix lists. But if you want to do it automatically and on a regular basis, you need to build some kind of infrastructure around that to do it, to pick that things together. And we decided to provide an example of such infrastructure. We took some scripts and tools that we use in our own company and polished it and published it as an example. You can find it on that URI. And what we have, we run tens of Linux servers with BERT routing daemon. And because of that, we have some requirements. For example, we do not want to handle and maintain all configuration by hands because it will cause errors and so on. And also we want to reuse the prefix list so that we should not flood routing registry with our requests. And so we published the scripts on the URI, and there are three main components. There are Ansible playbook and templates that allow you to generate your BGP configuration and filter configuration. There is a Docker image that provides HTTP API for fetching prefix lists. And there are scripts that do the jobs on nodes, fetch prefix lists and generate bird configuration and reload it. For example, in Ansible, you can configure your PS with such YAML configuration, and you will have output something like that. Then I have many slides just for the reference. And in that Docker image, we use under the hood the BGPQ4 tool to fetch actual prefix lists. And we cache the result with Nginx, and it also provides an HTTP interface. And with the URI like that, you can fetch a prefix list for ISET or IS number. Also, in that image, we aggregate prefixes with Plague tool. It's our own tool. We also published it. And we wrote it because it is, I did not find some good solution that works fast. Other tools are either slow or do not support IPv6, and also some of them do not make you a perfect aggregation of your prefix list. And this tool makes it best it can, it gives you minimal aggregation that is possible. And in those scripts that generate prefix lists, we use such URIs that fetches aggregated prefix list. And okay. And I think that's all for introduction. And if you have questions,
right, please raise questions directly to Alexander. We are really short of time, and we still have a lightning talk.
Okay.
Right. Thanks for this. And now to finish up the routing working group session, a picosecond length lightning talk.
All right, I'll try to be as fast as I can. It's one slide. Okay, so many of you will know that at NLNet Labs we make Krill and Routinator. But what not everybody may realize is that we also have a common Rpki library that is open source and available to anybody who wants to do stuff with Rpki in Rust. So it has objects, support for the basic object types, let's say, used in Rpki. All the logic about validation or creating and signing things is in the other stuff. So it's the intent is to keep it small and simple. If you made a different life choice and you do Java, then I recommend that you look at Rpki Commons, open source by Rpki. Any questions or comments about this, you can go to GitHub or email us or talk to us. That's actually all I had to say.
Excellent. Thank you so much. And with this, we officially are 4 minutes over time, and that is the end of the routing working group session. Enjoy your break.
Good morning. We are going to start in 1 minute, so I kindly ask everyone to take a seat. Since it's already that quiet, I think we can just start. Hi, and welcome to the DNS working group session. My name is Moritz. This is my first meeting as a DNS working group co-chair. Thank you, and thanks for everyone who supported my submission. I work for SIDN. For those who do not know me, we are the registry of the .NL CCTLD, and I do all sorts of research on DNS and DNS Sec, and I'm also a part-time researcher at the University of Twente. Just a brief look at the green button, I assume. The green button. Okay, here we go. Brief look at the agenda. We have 2 remote presentations today from Sarah, and one presentation about kind DNS from ICANN. The other voice, other people are hopefully in the room. And I think with that, we can already take over to Sarah for the first presentation on the DNS over QUIC.
Okay, so hopefully you can see my slides and hear me.
We can hear you, but we cannot see the slides yet on
Okay, hold on
our screen here. We can see the slides on MetaCode though, so.
Oops. Okay, maybe let's have a look. Let's cancel that. Okay, if I stop sharing, do you want to try and share them directly then?
Yes, please share the preloaded slides and then.
Yeah.
Another try.
Oops.
Yes, we can see your slides.
Okay, excellent. Right. Thank you very much. Yep, today I will be talking on DNS over QUIC, or Doq, as it tends to be called. I had to update my slides because this became an RFC literally last week, RFC 9250, and I'm a co-author of that RFC along with Christian Huitema and Alison Mankin. So the topics I'm going to try and cover today are: why are we standardizing yet another protocol for encrypted DNS when we already have 2? And to do that, I'll try and describe how DOQ works and how it's different to DOT and to DOH. And I'll also talk about where we are in terms of implementation and deployment with DOQ. So firstly, a little bit of background on the QUIC protocol itself. It was originally developed by Google in-house, starting in 2012. They spent a few years developing it and decided that it was mature enough to move to the IETF to be standardized as a protocol. They did that in 2015. And at that point, the hope was it would only take 1 or 2 years to standardize it. However, in true IETF fashion, it actually took 6 years. And so QUIC was eventually standardized last year in RFC 9000. Now, it is implemented and used by browsers and CDNs, and the best figure I could come up with was that today roughly 8% of websites are using QUIC. The key characteristics of QUIC as a transport protocol are that it runs over UDP and it is always secured with a TLS 1.3 handshake. So there is no unencrypted version of QUIC. It is an inherently encrypted protocol. It has reduced latency in terms of its handshake, and it's relatively easy to achieve 0 RTT using QUIC. Importantly, QUIC is a multiplexing transport protocol. It uses multiple streams within a connection to achieve this. And the key win that gives you over using TCP is that QUIC suffers from no head-of-line blocking, and that's very important in its improved performance. In another gain over TCP, it has improved error detection and loss recovery, and this makes the QUIC connections more reliable and more robust under heavy traffic or to packet loss. QUIC also has a neat feature called connection migration, which means that two endpoints that have a QUIC connection between them can maintain that connection even as the endpoints change IP addresses. And that can be very helpful when you have a mobile client, for example. And Google developed QUIC to be the transport protocol on top of which they could run HTTP3 to give them enhanced performance for web traffic. However, it became clear very quickly when you think about the characteristics of the QUIC protocol that it's an incredibly good fit to do encrypted DNS. It has the low latency that's important in DNS, and you get all the benefits inherent in the QUIC protocol, but you also have source address validation built into the QUIC protocol, which is very important in DNS. And also with QUIC, the path MTU does not limit the size of the messages that you can send over UDP. So we started work on Doq quite a long time ago, but unfortunately its standardization was blocked by the standardization of QUIC itself, which took until last year. Now, just to reiterate the point about the similarities and differences between the different protocols, on the left here, you have the protocols running over TLS. So that's DOT and DOH. And DOH is where DNS messages are encoded within HTTP2 and running on top of TLS. On the right, you have DNS over QUIC, which is analogous to DOT. And what's also possible, and is a slight source of confusion sometimes, is that we already have the specifications to run what's normally called DOH3, where you encode DNS messages in HTTP3 running over QUIC. Okay, I am seeing messages that my audio is broken.
Yeah, we just figuring out if it's on your side or on our side.
I'm not sure. I'm just going to try and reload my audio here.
Could you stop and restart the audio?
Yeah, let me. Okay. Okay, let's see if that's any better.
Unfortunately not.
Okay, is that any better?
Sounds better, yes. Thank you.
Okay, all right, let's give that a try. Okay. Right, so on this slide, I'm just comparing the various protocols, and what we're going to focus on is DOQ running over QUIC. So the background to the development of DOQ, we originally wrote the first draft back in 2017 for this, and based on that, AdGuard actually created a stub to recursive resolver service in 2018 using that initial specification and have been running it ever since. However, it took until 2020 for the draft to be adopted in the Deprived Working Group at IETF, which is the working group concentrating on increasing privacy in DNS. After working on the draft for a while, the following year, the 03 version of the draft contained several big changes. First of all, it rescoped it so that it wasn't just stub to recursive only as DOT and DO currently are, but it also covered zone transfer and recursive to authoritative as well. The mapping was updated slightly, and we made a port request for port 853. I'll touch on both of those topics in a later slide. After those updates, we moved into last call at the end of last year, and then just this month it was approved for publication as an RFC. So firstly, a quick look to go back to thinking about what the Doq handshake looks like. This is an image blatantly copied from a very good blog by Cloudflare, who have several blogs about Doq, so I'd recommend reading them. And as you can see on the left, when you're using TLS over TCP, you have to set up the TCP connection first and then do the handshake for TLS. Whereas in Quick, the connection setup and handshake are combined into the initial exchanges, so it's much quicker. Doq also has its own ALPN, as does DOT, and this is one way to distinguish them. Looking in more detail at what the Doq connection itself looks like, so inside a Quick connection, there are streams. There are different types of streams. The kind that Doq uses is a bidirectional client-initiated stream, and those have IDs which are multiples of 4, so 4, 8, 12 upwards. The mapping for Doq uses a single stream for a single DNS query response transaction. Then that stream is closed. Now, streams are readily available inside a Quick connection. There are 2 to the 64 stream IDs available, so you can send a lot of messages inside a single Quick connection. And in the mapping, to avoid any conflict between the DNS message ID and stream ID, we always set the DNS message ID to 0 for messages within this connection. And that's just something that has to be kept in mind if you want to proxy to or from Doq. Now, I mentioned that the mapping changed slightly. In the original mapping, the encoding was directly of the DNS messages into the stream. However, that presents a limitation that you can only send a single response on a stream. So in the 03 version of the draft, it was updated so that we now prepend the DNS message with the 2 octet length field, just like we do in TCP. And this provides the flexibility so that servers can then send multiple responses within a stream, and that means we can support zone transfer where a single zone transfer takes place within a single stream. As I mentioned, one of the other updates in the 03 was that we specifically defined Doq as a general purpose protocol for DNS encryption. And the draft describes 3 scenarios: the stub to recursive scenario, which there are already running services for, and which claim good performance, particularly in mobile networks, which is something you would expect with Doq. Specifically, the recursive to authoritative scenario. And it's thought that Doq is more attractive here than other protocols because it should certainly be more performant than DOT, and it's lighter weight than any of the DO options. And we also specifically define that it can be used for zone transfers. Last year, RFC 9103 was published specifying how to do zone transfers over TLS, and using Doq for zone transfer is a direct extension of that specification. There was quite a bit of back and forth over what port to use for Doq. We originally suggested a port 784 it was, because back in 2016 when DNS over TTLS was being developed, port 853 853 was assigned to DNS over DTLS. However, it was recognised that DNS over DTLS has remained an experimental specification, and to my knowledge, it has no implementation or deployment 5 years after specification.
Can you hear me? Your sound seems to be going south again.
Okay, I've reset audio again. Hopefully that's better.
Yeah, seems to be better. Thank you.
Okay. However, after some discussion over port allocations, it was finally agreed that Quick could also use port 853. And one of the reasons this is possible is that Quick version 1 was specifically designed to be able to demux with DTLS. There's a magic bit in the header which lets you determine which protocol it is. Looking at the existing implementations for Doq, I've listed the open source ones here. Kudos to AdGuard, they open sourced all the code that they used for their resolver service. On the server side, they used an extension of Core DNS written in Go. On the client side, they've got some C++ libraries. There are another couple of libraries, one in C and one in Python if you want to experiment, and there's an experimental trial of Doq in Flamethrower, which is a DNS performance utility. To my knowledge, there are no implementations in any of the major open source recursive resolvers or authoritative, but I am hearing very encouraging statements from some of the big operators about wanting to do trials and wanting to move forward using Doq. And in terms of actual deployments, there are two that I'm aware of, AdGuard, who've been around for a while, and there's a separate service run by NextDNS. There was also the first academic study of Doq last year, and that actually identified 1,200 Doq resolvers that would answer when they did probing. And that's quite an interesting study on the current state. In terms of recursive to authoritative, there are still lots of ongoing discussions in dprive about how various authentication mechanisms would work in that scenario. But there is a proposal for how to do unilateral probing. And Doq lends itself to this in the same way that Do does, in that you can just probe port 853 to see if a server answers. And it looks like there's some interest in using Doq to experiment with unilateral probing recursive to authoritative. There's a little bit of ongoing work in that there's still, it would be nice to do some more work on padding. We're still using experimental specifications to pad encrypted DNS traffic. Some implementations observed in the wild and the academic study that I mentioned were not fully optimized and weren't quite achieving 0 RTT when they should be. That was due to what appeared to be implementation issues, so that can be looked into. And one of the key things with Doq is that we're still lacking any formal performance measurements that directly compare it to DOT and to Do. And I think this would be particularly helpful to encourage people to consider it for recursive to authoritative deployments. So in summary, DNS over Quick is now an IETF standard. There are several stub to recursive Doq deployments in use today, and it looks a likely candidate for recursive to authoritative experiments using probing. And if you want a little bit more background on Doq or on general work on DNS encryption in general, you can have a look at the dnsprivacy.org website that tries to maintain more recent developments in terms of standardization and deployments. With that, I will thank the audience for putting up with what I understand was some tricky audio at times, and I hope we have time for a few questions.
Thank you, Sarah. We do have time for questions. Are there any questions? Yes, one apparently.
Hello, I'm Carsten from Sys4. Sarah, thank you for this presentation. And sorry that I didn't use the app, it didn't work on my devices. My question is, for DOT, for DNS over H, no, for DOH, for DNS over HTTPS, it's possible to use web server software like Nginx to proxy between HTTPS and DNS. Are you aware that this is also possible, or do you know if that is possible with DOQ as well? Because Nginx supports Quick already, and it might be possible to have quick installations with that, pun intended.
Thank you, that's a great question, yes. So those proxies do support Quick. The last time I looked, which was a few weeks ago now, they didn't yet have native support for doing DNS over Quick. I would hope that that is coming. I wrangled with the configurations and I couldn't find an easy way to do it. So I will be planning to open issue with the implementers just to raise awareness that now it's a standard, people would be interested in trying that out using those proxies. Yeah.
Thank you. I will play with that, and if I find a solution, I will let you know.
Thank you.
We have one more question in the queue by Brett Carr, and then also one question in the Q&A. Brett?
Hi, good morning. Yes, can you hear me?
Yes, we can.
Excellent. Sarah, thanks for the presentation and congratulations on the RFC. I think it's been a long time coming, and I've seen bits of this presentation several times before, and it's always interesting to see. It feels like DOQ is a bit like the second coming for DNS. It solves lots of problems we've had for many years. And you know, you in your presentation you talked about where the areas of DNS where you thought it was suitable, which seemed like all the areas of DNS. But I just wondered if there was any areas of DNS where you thought the DOQ was not suitable or less likely to get deployed.
I can't think of anything immediately in terms of the actual specification. I think the challenge will be the practicality of implementing it, because I think, as some people have already mentioned, the ease of picking up quick libraries and integrating it with existing DNS software could be a bit of a challenge. So I think it will depend on how much work that actually turns out to be in practice for some of the major open source implementers. It's not quite as easy as fit as just picking up OpenSSL and putting it in. You have to think quite hard about what library, what the API looks like, because they do vary quite a bit. So I suspect there'll be an initial implementation hurdle. But once that is overcome, I really do hope that we will quite rapidly see performance data that makes clear that that is a cost worth paying to deploy this.
Okay, thank you.
Thank you. Before we go to the last question, Sarah, could you try to fix your audio once again? And in the meanwhile, I hope you can hear me still.
Yep.
I will read out the question by Alan Burns. Does DOQ support updates as well as queries?
It does. Have a look at the draft though, because there is some advice about use of 0RTT for updates as opposed to queries, because there is a potential privacy issue there. But yes, there's no reason you can't do updates over Doq as well.
Okay, thank you. With that, another round of applause for Sarah. And we go to the next presentation by Petr Spacek about DNS catalog zones.
We have slides, excellent. Hello, my name is Petr Spacek, and I work with ISC on basically all things DNS. In this talk, we will briefly look at catalog zones, what it is, what problem it tries to solve, why is it interesting. So, first the problem. Well, it's generally the management problem of DNS because the protocol just don't have any management built in whatsoever. And if you have lots of slaves or secondary servers, as we call them now, it's harder and harder with the number of zones you have. So for single zone, it's simple. In case of bind, it's like, you know, this name of the zone, IP address of the primary server, that's it. As the number of zones increases, it gets messier and messier. And as you add servers, it's even worse. At some point, it's just unmanageable. And if you have lots of zones or lots of secondary servers or frequent updates or any combination of these three, it's just mind-blowing. It's not a new problem, obviously. So anyone who had that problem already has a solution for it. The great advantage is that it actually works. So it solves your problem. But the disadvantage is that it solves the problem only for you. And as soon as you want to modify it in any way, say, migrate to different DNS implementation or add another implementation to the mix so you don't rely on one vendor but use two, you have to modify all the magic scripts which do the management. Or if you want to, say, use an external party to serve your zones as a backup, it's even worse because external party is usually not driven by your scripts. So to solve that problem, it's actually pretty hard. DNS vendors were thinking about the generic DNS provisioning, like overarching protocol for a long time. Many people in this room tried and failed over years. But the thing is that if you really focus on one specific problem and try to limit the scope, it becomes much more manageable. And that's what the catalog zones try to do. Essentially, the observation here is that on the secondary server, typically, you have a huge list in the configuration file, but almost the only variable in the file is the zone name, which is changing, and all the rest is almost the same. So let's try to use that. Well, but we are DNS engineers, and as the old saying goes, if you have a hammer, everything looks like a nail. If you are a DNS engineer, you know zone transfer, so everything looks like a DNS zone. So this is how we arrived to the so-called catalog zone, which is a like DNS zone, which contains list of zones. It's really weird when you hear it the first time, but the reason why we are going to this direction is that once we have data in form of a DNS zone, we can use zone transfers, notifies, and all the mechanisms we already have built into the servers. So it doesn't require lots of new code. It's actually proven technology. So we can try to use that. The obvious catch is that it's kind of confusing because it's configuration formatted as a DNS zone. So it's not actually a DNS zone. There is nothing, no DNS client actually querying the zone. There is no client which is supposed to get the records. It's just a configuration for the secondaries. But let's get over that. It's just one zone which will rule them all. So before we dive into specifics, let me warn you, there are two versions. The version number 1 was used by ancient versions of bind. It's still supported, but you really should use the version 2. And the reason is that the version 2 is actually joint work of multiple vendors, and it can actually work with different implementations at the same time. Approximately a month ago, during the ITF in Vienna, there was a so-called DNS hackathon. And during that, we did an interoperability testing with different vendors. And we verified that actually the version 2, as implemented now, works between the latest version of bind, released just yesterday, Node.js version, and also the upcoming version of NSD. I have to say that not all names are on the slide. So if your name didn't fit on the slide, I'm sorry, but it's not personal. It's just a small slide. It was a lot of people working on this for a long time. Yeah, if you open documentation, don't be surprised. There are cats all over the place just because we can. Finally, the technical part. What it actually is. Again, it's a configuration file, but it looks like a DNS zone. So it has to have some zone name. It can be completely arbitrary name. Just use something which doesn't clash with anything you use in the DNS tree. No client is going to query for it. So the name is completely, can be completely random. Then again, it's pretending to be a DNS zone. So it has to have SOA records. It has to have NS records, but they are not actually used for anything useful. Then the important part, version number. That's really important because there are two versions. If you forget the version number, it might accidentally work, but it's bound to break on upgrades. So just put the number there, don't forget. And finally, thank you for bearing with me. We arrived to the last two lines, which are the reason why we are here. It looks like PTR records, but it's not actually PTR record. It's the way how the catalog zone encodes the list of zones which should be provisioned to the secondary servers. So here we have domain.example and domain2.example, and these two zones will be provisioned to the secondary servers automatically. At the beginning of the line, we have some random IDs. It can be random, it doesn't mean anything, it's just internally used in the protocol. Just make sure that they are unique and that's it. So we've specified a catalog zone in form of a text file. Now we have configured the servers. First the primary side, and luckily there is nothing special, literally, it's just a zone because it pretends to be one. So you just configure name of the file, the type primary, name of the catalog zone, that's it. Of course, the primary has to provide the data for the domain or zone you want to provision. So the configuration is all the same, nothing special here. If we go to the secondary, it's a little bit different. Again, the beginning is the same as usual, name of the zone, name of the catalog, IP address of the primary server, which contains the zone. Then the secondary will fetch the catalog, but from the perspective of the DNS protocol, it's just a zone. It pretends to be one. So there needs to be special magical configuration here, which enables the special behavior for that particular DNS zone. So once the zone is transferred in, the server will look inside the zone, find the PTR records, and based on the PTR records, it will provision the secondary zones. And of course, only name of the zone is not sufficient because the secondary server has to know where to get the data for the secondary zones. And that's the reason why the IP address here specifies the IP address of the primary, where the zones listed in the catalog should be transferred from. Okay, so we have configuration. How does it work in practice? Let's start in a situation where we have the primary server configured with a catalog zone, secondary server configured with a catalog zone, but no other zones are in the catalog yet. So this is the step 0, basically. And then we provision first zone we want to serve from all our secondaries to the primary server. So we modify the configuration of the primary in the text file as usual, call whatever command is needed, and the primary will reload the zone, nothing special here. Also, the primary will send out notify messages. That's the first line here. But at this point, the secondary doesn't even know about the zone we just provisioned. So it will probably log, I'm not authoritative for this, go away. Then we modify the catalog zone. We will add the PTR record with name of the zone we just added. And then again, the primary will send out notifies for the catalog zone. But the catalog zone is actually configured there. So it will accept the notify here. That's the line number 2. And it will transfer the catalog zone as it does with all other secondary zones. And then it will parse content of the catalog zone. Notice a new zone, which is line number 6 over here. And then once the zone is read from the catalog, it will immediately start the zone transfer from the primary, which is the IP address in the configuration file. So it will transfer the zone to the secondary and start serving it, and that's it. So with this setup, we didn't have to touch the configuration file on the secondary when we added a new zone. That's it. As I was mentioning in the beginning, this protocol actually interoperates, so we can use different implementation on the secondary side. It will just work. This is configuration for Node.dns, and well, essentially it's the same. I mean, it has to contain the same information. It's just different format, and that's it. So again, we have name of the catalog zone here, IP address of the primary server to get the catalog from, and the special magical option which enables the special interpretation over here, catalog role interpret. That's again instructing the server to interpret the PTR records inside the zone in a special way. Exactly same as for bind, we need an address where the secondary can get content of these zones listed in the catalog. That's done using this template, using this special Node.dns configuration format. In practice, the log is again saying the same information using different terms. On the line number 1, we get the notify for the catalog zone over here. Then it will transfer the catalog zone as usual. And then again, it will notice that, here is a new zone in the catalog over here on the line number 4. And then it will provision the zone to the secondary, transfer content of the zone, start serving it, and that's it. Looks simple now. Didn't look like it when we were implementing and developing the protocol. Anyway, this is catalog zones version 2. Use please version 2, forget about the version 1. It's actually interoperates between different implementations. The latest version of bind and Node.dns can do that. Version of NSD with support for that is coming, I'm being told. If you are interested in more details, there is a full specification of the protocol available. The slides have, clickable link over here. And if you want to discuss with people behind the protocol and behind the implementations, you can click on this link and it will lead you to the DNS org chat. And in the chat, you can find all the people behind the protocol. It's open to anyone. You just register using your email, and that's the only requirement. That's about it from me. Thank you for your time and attention, and hopefully we have some time for questions.
Yes, we do. Thank you. First, Matthijs.
Matthijs Mekking, ISC. A little bit more about the version 1, because we might be a bind user already using catalog zones. And if you're still using version 1, indeed, update to version 2. But also the existing custom properties like allow query, primaries, you have to move them to the exterior property. Yeah, there's an ext. So all those things will still work, but you have to move them under that label according to the specification.
Yeah,
so that's for your migration plans, a little bit of information.
Yeah, just read the docs. It's in the documentation.
Lars Lima from NetNode. Could you explain, please, why you decided to overload existing record types with new semantics?
I can't explain that.
Who can? Someone came up with that idea, and I want to have a serious chat with that person.
Yeah, it's in the midst of the history, and that's exactly why I put the link over here. You can express your opinions.
All right, I will. Thank you.
Yes, go ahead, Janssen.
Jelte Janssen, SIDN. I actually had an original question about that as well. This sounds like something that could use a cat class even. But
isn't that blasphemy? This year?
Probably. No, but it's nice to see you have something that's very useful without going into the camel hole of a full name server control thing through zone. So kudos. But can you also, the example you used uses AXFR. Can you also tell it to use IXFR, for instance?
It's normal zone. The zone transfer is all the same. The only thing which is different is interpretation once you have the zone. So it's no different from the perspective of transfers.
Okay, cool. Thank you.
And I will cut the queue now. Thank you. And one question remote, or a more comment, I think, from Peter van Dijk. If you're an operator and you're interested in sponsoring the implementation of catalog zones in PowerDNS, please reach out to me. That's Peter van Dijk at powerdns.com. And then another question, actually a very long one, from, sorry for butchering the name. Yeah, I don't even try, sorry. Can secondary support multiple catalog sources?
Yes, it's normal zone again, so you can have as many as you want, and you just declare in the configuration that this is the list of zones which have this special magical behavior.
Okay, and the second question, what is the impact of changing the random ID associated to a given zone? Is it a convenient way to flush it at the secondary? For example, trigger, XFR, whatever the previous store serial?
Yes, it's basically the same as if you remove the zone and edit again, so yes.
Okay. And in terms of time, I will skip the last question and give the floor to Neil. Oh.
Yep, that works. Two comments. I think the answer to Liman's question is Paul Vixie. I seem to remember long years ago mails from him about this concept, and I think that's what made it into version 1. The other comment is, or it's a question or a comment, is it the case that implicitly in the, if you like, payload zones, the primary is the same primary as the catalog?
Not necessarily. If I manage to go back enough to the slides, it's not working anymore. There's different configuration for the catalog zone itself and for the zones listed in the catalog. So you can have different sources for these two sets.
And one more last question by Brett, but I kindly ask you to be brief.
I will try to be brief if I can. First of all, I was talking about Neil just said about it being Paul Vixie's fault. He floated this idea past me back in, I think, 2004, and that was in there then. So it's been a long time coming. Secondly, I wonder when the secondary picks up new zones from the primary as part of the catalog, does it write those into its configuration file? I'm assuming it doesn't. And if it doesn't, is there a way for me to get a list of the currently configured zones?
That's something the protocol doesn't prescribe. That's implementation specific. I can talk only about bind. In case of bind, the zone will get written to disk, so you have files on disk, and you can have a look, and you can work with them using the RNDC interface as usual.
Okay, and secondly, very quickly, I wonder if there is any way within the protocol or within the specific implementations for there to be some concept of approval of a zone before it's added. So, for example, I might have a relationship with a primary provider who I give permission to add new zones, but I don't want them to suddenly add 500 new zones at once.
Okay, that's again something that protocol doesn't prescribe. Can be implementation specific thing for like rate limiting or whatever you can come up with.
Is there any concept of that in the current implementation of bind?
No, it's not. It's just normal zone transfer, so whatever is in the zone will get loaded immediately.
Okay, thank you.
Thank you.
Thank you.
Then we have Joao.
Hi, Joe Damas, working with Jeff at APNIC, doing experiments on measuring the internet. And today's measurement, we are going to report about which resolvers people use, and particularly in the context of this. I don't know if how many people here are aware of the DNS for EU? I don't know what to call it, initiative? Okay, good. The text that's there is probably not what they said, but I think it's what everyone interpreted. And that's what at least I had in my mind when I started hearing about this DNS for EU thing. And I understand why they might be thinking along those words, even if they're not speaking them out loud. But anyway, if this is the premise that's behind the whole effort, how true is it? Is there a problem? So we decided, Jeff and I, to go and see what resolvers people use. And it's like, what does this mean? How can we measure it? So as you probably have seen throughout these last years, we have this experimental rig where we use ad placement by Google's platform ad, which has pretty good reach. I think currently there is only one country that stopped getting ads since late February. But everywhere else you can get ad placements with Google. And in principle, what this lets you do is a very simple activity, which the JavaScript that you embed in the ad can perform a web fetch. But with each web fetch come DNS resolution queries, right? So that's what we use. How do we craft that? There's a few prerequisites that we need to get this done properly. As you can imagine, when you as a user query something like quad 8 or quad 9 or quad 1, that's not the address you see at the authoritative servers as being the source of the queries, right? That's the only the address that you present to the end user. So if we are going to find out who is behind each DNS query, first thing you need to do is assemble a list of these IP addresses that those engines use to perform the actual queries. Now, people like Google, for instance, very helpfully provide web pages where they list those IP addresses. Other people, it's harder, but if you do the homework, you assemble this list and then you can use it. Once we start seeing the results of the experiment, we tended to classify them. Is the resolver we see asking in the same AS number of the user that asked the question that we sent the URL that it had to fetch? Does it belong to an open resolver? Is it geographically nearby, like in the same country? Or is it a completely different origin? So when we did the first iteration of this experiment, what we observed is that in about 73%, 3/4 of the cases, we saw one query by the client generating one query by one resolver. But on average, if you count them all, for each experiment we see for each DNS query, the URL fetch, sorry, we see 1.65 queries from distinct IP addresses. And this has a little bit to do with how clients wait for the response to come back and how impatient they are sometimes. But also how these open resolvers use their pools of machines to do the work, and how their internal communication or lack of internal communication sometimes triggers more than one request. Okay. So in the first iteration, we took all these queries independently of where they were coming from and just categorized them and added them together. The question then that arises is, okay, we see some people using more than one resolver. Can we actually design an experiment that flushes all the list of resolvers that people have configured in their equivalent of a resolve.conf? So we adjusted the experiment. We rewrote the DNS server we use to have one experiment type where the response that the client gets, the resolver gets, is always serve fail. If the resolver gets serve fail, it will communicate back that to the client, and the client will be basically forced to iterate through the list that it has. And in that way, you basically shake the tree and get the full list for every client. What is their list of configured resolvers? And what we do we see when we do that? Most people, 3/4 of people use resolver that on their or have configured the resolver that on their ISP, the ones that you get configured by using the ISP. Then 26% people have Google configured as in their list. And the additional 9% people have resolver that are in the same country. And then the fourth category was Cloudflare, which was at 6%. The graph shows you the evolution since we began the experiment. And all this data is available on the stats.labs.debugging.net websites. If you want to look at it for your AS, for your country, and so on, you can easily go there. So what this previous iteration of the experiment, the second iteration of the experiment, gives you is all the list of configured resolvers on the user's machine. That doesn't mean the user gets to use them all the time, or even at all. And the normal thing would be that the user uses only the first one. So the fact that you could potentially use all these resolvers doesn't mean that you will actually use them, at least in normal operation. So which resolver provides the answer that the user will actually use? So we went back to the first experiment, but instead of collecting all the queries and adding them together, we said, okay, well, let's filter out only the first, select only the first answer that we provide to the user, and take that as the one that the user is actually going to use. If you do that, you get slightly different results. Same AS, so the ISP provided recursive is used by 71%. Google goes down from 26 to 15%. In the first iteration, I don't remember seeing the graph, it was around 16%. People who use resolvers in their same country are around 7%, and Cloudflare also goes down a little bit from 6 to 4%. So in summary, those are the numbers we got. And of course, when you see these numbers and you have to define, or if someone asks you, what's X, someone's market share, there's of course different answers depending on how you define the question, right? Is it 20%, 26% for Google, or is it rather 15? Well, as I said, depends what your question is. The answer will be different. There's also the question of who is we. When we say the resolvers we use, who is we? The ads, they spray everyone that gets online, basically, because that's one of the good features of Google, at least from our point of view. Maybe if you are on the receiving end of the ad, not so much. Enterprises are usually free to do whatever they want within their little regions of authority. So how about we take the previous data and we cross-correlate these data with AS numbers that we know belong to consumer networks. So the typical home ISP, right? In that case, what we get is different. The people who use the same, the resolver in the same AS, so usually their ISP provided, goes up to 87%. Same CC, so not the same AS, but the same country still, 6%. I must say that one thing that we observe is that there are several ISPs out there, particularly big ones, that separate the access network from their internal services network. So the two ASs actually belong to the same organization. It's just how they organize their network, right? So there's a very high likelihood that the same CC actually means the same company, just a different network that belonging to the same ISP. And Google goes down to 4%. This is, again, I remind you, home users, and Cloudflare to 1%. So what this is showing is that for consumers, people like you and I, when we are at home, actually the vast majority use what their ISP gives them. And in that sense, you have to wonder if there is a problem. The picture for enterprises is, as I said before, different. And you can see these very clearly from the weekday, weekend pattern. It was also very visible at the beginning of this whole lockdown period, when everyone suddenly started working from home rather than the office. There was a clear shift in the graphs showing that when people stayed at home, Google usage was down. So it's things pointing to it being the enterprises or enterprise networks that actually use OpenResolver the most. So is there really a problem then in the context of DNS for you? Well, depends who you are and how you phrase the questions, right? As we said before, majority users at home use what their ISP gives them. They don't give their data away. Probably they don't even know that there is such a possibility. But there is increasing concern on these open services, open servers, open recursive servers becoming centralized points of DNS operations. So it's not yet a problem, but it might be. What can we possibly do about this? Perhaps there are better ways than the approach that the European Commission was proposing, which came with a lot of strings attached, and it basically created a different set of centralization problems rather than eliminate them. And if throughout all these years, it's been known to everyone, particularly people in this room, I think, that the internet works best when it self-regulates, when it's the people who run the networks on behalf of the users that do the self-organization. So how about we think of a different approach? If there is going to be a problem, if there is going to be a concern, there is room for us, the people who run these services, perhaps, to come up with a set of operational practices that people could subscribe to, adopt, and point to as a reference as this is how we operate our network. And then anyone who puts up an open resolver service could just subscribe to these as this is how we do things. Traditionally, RIPE has been a rather good venue for coming up with these sets of rules because the people who run the services are actually the ones who attend RIPE. And RIPE has had in the past ways to do this kind of thing quite quickly in the form of task force. So that would be my question to the working group. Is this something that has any sort of, does this raise any sort of concern first? Is this the proposed approach something that you see feasible? I think I've seen within the center community already some loose threads about how about we define what we think is a good open resolver. So of course, center is also well represented, at least the members of center are represented here, and they will be welcome to participate. Is this something that the working group says as a work item that it can adopt and then publish whatever the outcome is? And if so, would a task force be the right way of conducting this quickly, or do you prefer to just have the whole room participating at the same time? Thank you.
Thanks, John.
Oh, wow. Cool, Jim. Thanks.
Yeah, thanks, Jim.
Hello, Patrick Tarpey from Ofcom. Really interesting study and something that I've been rolling around in my head about this, but the emergence of oblivious technology, in particular oblivious DoQ, and more recently we saw the the beta release of Apple Private Relay. If those were, shall we say, more widespread in their adoption and became ubiquitous, what would you expect to see in terms of the results? My initial reaction is Apple Private Relay kind of disintermediates the ISP resolver service. So would you expect naturally to see more traffic emerging from, you know, the Apple private relay partners and in general oblivious?
Yes, we would probably see the increase in delocalized traffic. And in fact, we are already seeing a little bit of that, partly from Apple's deployment of this thing, even if though it's supposedly beta, but it's actually working, but also from VPNs. And we have to do some manual filtering of the data carefully, because we are increasingly seeing queries coming from places that look like data centers, which don't have any real users. We know that, but are endpoints for these sort of VPNs which are also becoming more and more popular. The problem, of course, with VPNs is that there is no two-stage decoupling of who is asking it and what they are asking. So you're just shifting your problem to someone else who probably don't even know who they are. So the disintermediation approach, I hope, it will catch, and it will address perhaps some of these problems. It will convert it in a different problem. For instance, Apple uses, I think, Cloudflare as their second relay. And although you decouple the two pieces of data, I wonder if that will be enough to put people's concerns to rest.
So just a supplemental question, are you planning to rerun it again, this series of tests?
It's constantly running.
Oh, okay,
so
cool.
The scripts are running every day, and the data is being added to the website, and we will tweak the experiment as we see how the internet evolves.
Thank you very much.
You're welcome.
I have to cut the queue now, and for the people in the queue, please be brief.
Peter Hessler with Openbsd. I have an anecdotal piece of information for one of your questions you asked, which was when you did the serve-fail test, where you saw a huge amount of traffic going to Google, and then not so much with the so-called actual testing.
Mm-hmm.
I have anecdotally seen on a handful of networks where they hand out their own resolvers, and then also Google Public DNS.
Yes.
So as the fallback in
Yeah.
case their own fail.
Yeah.
And so that is potentially
Exactly.
where you're getting that information.
It is, yes. It's exactly the behavior we see. And I mean, I cannot fault them. We don't want to be called at 4 in the morning.
One comment from the Mitico. Antonio Prado says, thank you for this presentation. Just a comment. I think the initial statement could be just part of the story, because among the DNS4U requirements, there are GDPR compliances, bylaw filters, optional parent control, and wholesale paid services.
Yes, and that's a little bit of the concerning part of the DNS4U proposal. There's a lot of wording there about control.
Hello, Kavaraj for Rpki. Thank you for the presentation. I think we need to rethink and reframe the whole question and see if even if that such an effort is valid, because namespace is a shared and limited resource, so that's of course there. But the whole infrastructure discussion is about resolution, which is not a shared, not a limited resource. It's basically more options for people. And the first question I think is, will an EU or anybody will have the right to regulate when there is free choice already for citizens, correct? And if I want to go to a website, my ISP doesn't resolve, I have every choice to switch to Google or whoever, and I can switch back. So that's, I think first we have to start from there. So that would be a very good starting point for such a task force. I fully support having a task force on that, because I think we are trying to regulate somewhere where the regulator doesn't even have the right to regulate. So entering that provides control. And we are forgetting that it would create a set of elite people who say, yeah, citizens of EU don't understand, and we decide for them, where they have every choice. And of course, one person might not make a change, but if something goes wrong and I want to go to a website and my resolver doesn't resolve, I have every choice to switch to another one. Or if I'm worried about my data, I actually might not want European resolvers to have my data. It's my choice.
Yes, exactly.
And nobody gives them the right to regulate where there is not a shared and limited resource. So I think we have to start a discussion from there. Thank you.
Okay, thank you.
And one comment again from Mitico. Marco Ditri says, the actual question is, why are consumers using non-ISP provided resolvers, which have downsides like bad mapping from CDNs? My non-scientific guess is that this happens because their ISP's resolvers are A, censored, B, provide unwanted ads, or C, are unreliable. Okay.
Jim Reed, freelance consultant. Nice work as always, Joe and Jeff.
the ad network stuff you're doing is fantastic. Your suggestion about doing some kind of BCP or something along those lines is a good one. The problem I've got with the working group looking at the moment is we don't have a lot of representation from big operator networks that have got large number of eyeballs using big resolving infrastructure. We would need to have more of that kind of input if we were to produce such a document, and if we can encourage those people to come here, that would be great. The second point is, I think, is more of a layer 9+ issue, which is, to me, the objectives of DNS for EU seem rather unclear. We're not really sure what the intentions of the Commission have about this and what the long-term goal is going to be. Is it going to be in regulation at some point in the future? Is it going to be an opt-in service? Are they going to police it? And if so, how? So those questions, I think, need to be asked, and I think in some senses challenge the Commission and what they're thinking of that is. And that's maybe more of a role for the NCC's government engagement folks.
Sure.
But we might need to start articulating what those questions and concerns would be. That might be something else this working group could take on.
Sure, and I mean, this suggested piece of work doesn't actually preclude the governance side from having its own parallel. It's just making it easier to. You don't have to think so hard about this if your stated goals are your real goals, because here is an alternative that was actually developed by the industry.
Yeah. Just one other quick point is I think there's it's just to point out there are a bunch of now these so-called protective DNS services that are being used particularly in the public sector in various countries, and maybe that's another part of what the EU is thinking. I don't know.
Thank you. Benno Overeiner, Untitled Labs. Well, we repair that later. Well, the good thing is after Jim, he says a lot of sensible things, so I can be short. I think it's good to think about the task force. So this is a +1 for me. And I'm not sure we will be successful. Again, reiterating what Jim said, we have to also find other venues, but happy to help, give input, etc. So I think it's good. And this also reflects my discussions with other operators or people at the center. And yeah, thank you for the presentation.
Okay, thank you.
Thank you. Thanks, Joe. Now we have another remote presentation from Adil about kind DNS. Adil, are you there? Hello? Can you hear us? Adil, we can't hear you, if you can hear us.
I can hear you. Hi.
Yes, we can hear you now. Thank you.
Thank you very much for having me for this session. We'll start by saying I'm not David Huberman. Doing this presentation for him, but it is an initiative that I'm leading at ICANN. This is something that we consider as one additional tool to promote best practices and help secure the DNS ecosystem in general. Next slide, please. So, can I manage the slide from here?
Yes, you can.
Oh, okay. Right. So this initiative is called Kindness. We pronounce it Kindness for knowledge sharing and instantiating norm for DNS and naming security in general. The idea behind this is to work with the community to streamline best practices that we consider are critical for secure DNS operation. We want to focus to the operational aspect of this. And this came basically from feedback my team and myself have gotten from DNS operator in general. You all know about the Camel right initiative that identified that there is more than 200 RFCs that talk about the DNS, and I'm trying to, yeah. and more than 2,000 pages to understand the DNS in general. And our goal is not to make everybody DNS expert, but the idea here is to be able to identify what are the most critical practices that we can encourage operators to implement, being big, small, private, public, to operate a DNS that is secure and that does not become the weakest link of the overall system. We then start looking at the different documents that talk about DNS best practice, also talking with people who operate DNS actually on the ground, and identify practices that we can promote, practices that we can highlight. We usually say, the 20% practices that can help us achieve 80% of a secure DNS operational environment. So that is where this idea came from, and we started working on this since last year via mailing lists and working with the community and an external expert as well to help us streamline those best practices. The key component of the initiative, as I mentioned first, was to identify what are the critical best practices that we want to focus on, engage the community on those practices, refine them, and also allow them to evolve. This is not something that is cast in the stone forever, but it will evolve with the protocol, how the protocol evolve and how the operational practice also evolve. So based on what we identify, we develop the set of practice, publish them using a dedicated website for that, and add a component that is the self-assessment component as well. That self-assessment component will allow any operators to assess themselves against those practices, see where they fit, access the implementation guideline that we will publish as well, so that they can correct what they are not doing well, read more, and implement. And after doing that, or after getting through the self-assessment, they can enroll and participate to kind of, and participation mean becoming ambassador of those best practices, promoting them, and also voluntarily self-committing to implement them and keep them operational on their DNS service in general. Then we will also have a dashboard where we will identify a few indicators that can help us see if these practices are having positive impact on the, I will say, health, quote unquote, of the DNS in general. That will be a continuous measurement. We will try to streamline those measurements and try to focus on what we can measure from outside, but also involve people who are participating into this through some measurement that they can do internally, because obviously we cannot measure and see everything perfectly from outside. So those are the three components we are focusing on right now. But the idea is to later on extend this to the the procurement part of the domain name, which is more related to ICANN mission, which is the registry, registrar, and registrant best practices later. So through the exercise, we have identified in total 5 categories of DNS operators that we will for which we will document practice. Within the authoritative operators, we have operators that manage TLDs or critical zone. And here, critical zone, we participants will self-identify themselves as critical zone manager, but what we are putting in here are zones that are critical for the management of the TLD itself, like nic.tld, for instance, is critical for that TLD, or any other second level domain that are related to health or banking or insurance, can identify themselves as part of the critical zone TLD that are obvious. Then we have the second level domain manager or third level domain, depending on which TLD we are talking about, that will have their practice separately as well. And then we have the resolver operators, and there we have 3 different categories that we are covering. The first one is for closed and private resolver operators. That's mainly will cover, resolver that are run within companies, which are for exactly the user of a specific company or a specific community that is closed. We have share and private. That is mostly those you can see at ISPs. They are private, but they are shared by a limited group or known group of user. And then we have a public and open resolver in general. So for each of these categories, we have identified a set of practices that can be applied to each of them. Now, at the bottom of that, we have also set of practice that goes beyond operating the DNS itself. That is about the system. This came in not as part of the core of kindness, but it's obvious that if you don't have a strong platform on which you are running your DNS, you can secure your DNS as much as you can. The overall security will not have effect if your core system is not secure. So we have the hardening the core that is cross-cutting to most of these different categories, and operators can self-assess themselves against some of those hardening the core practice as well. So basically, those are the category that we are covering. And as I mentioned, an operator can join or participate to one or several of these categories, and by doing that, it's a voluntary engagement. Of course, when we started this, there has been a little bit of question about the relationship between this and ICANN remit, which is more about policy related to DNS registration. And as I mentioned, we are not touching the procurement part of the domain name here, but more the operational part, which makes this a very voluntary engagement and commitment by operators in general. So we'll quickly go through some of the practices that we have identified so far and on which we are working on. For instance, for the authoritative DNS operator for critical zone, we have so far identified 8 practices that are going to be documented, and which we are going to request any participants to adhere to commit to implement. DNS Sec is one of them, of course, making sure that the transfer between authoritative server is limited. So having a way to ensure the integrity of the zone file. Authoritative server must and recursive must not run from the same server. Those are simple thing that anyone that run DNS seriously know about, but we're trying to frame this in a way that people can quickly have access to those practices. For instance, for TLDs and critical zone, we suggesting that there are minimum 2 distinct name servers. They must ensure that there is diversity in their infrastructure, including software package they use on the different authoritative server they run. And they also have to ensure that they are monitoring their service continuously. I have 3 more minutes. So we have this set of practice for each of the category I just mentioned on the previous slide. For the SLDs, we have 7 practice. For the resolver operators that are closed and private, we have a set of practice as well. So for each of those categories, we have identified practice, and our goal was not to, go beyond 10 practice for each of the categories, so that we don't overwhelm operators with too much practices. That doesn't mean that we are not going to talk about other practices, because we plan to have a section of the website that talk about other reference, other things that you may want to do, etc., but focusing on this. And for having the core, right now we have 8 practices that are pretty much focused on the system in general. So the self-assessment and the enrollment, as I mentioned, anyone can take a self-assessment. You don't have to participate before you take the self-assessment. It's going to be open and available for anyone to take. And then based on the outcome, you can now decide to join Kindness or not. The self-assessment will generate a report that anyone can download. The report will also point to practices or guideline on how to implement practices where you fail, where you are not implementing yet. That is just a guideline, and it can be freely downloaded after you take the assessment in general. So all this is going to be published on a dedicated website that is being developed right now. Our goal is to launch this sometime by the end of this month, if everything goes well. And right now, what we are doing and what is happening is mainly streamlining the practice, and we have a mailing list for this that I will encourage you to join if you want to contribute to this, which is kindnessdiscuss@icann.org. And there is a wiki page as well that we maintain, and where we put information related to this temporarily until we have the formal website. Thank you very much for your attention, and I'll be very happy to answer any question related to this initiative.
Thank you, Adil. Unfortunately, due to time constraints, we cannot take any questions. I'm sorry, Jelte. Please take that offline. And with that, I give the floor to Florian from the RIPE NCC with a RIPE update.
Yeah, hello, I'm Florian of the NCC, and I will give you the DNS update. Let's do this quickly. First off, hosted DNS. This is where we, with the help of this community, expand our footprint of the NCC's Anycast services, KRoot and authDNS. We have been doing this for KRoot for many years, where we have 87 hosted sites. They cover about 50% of the total traffic of KRoot. The core sites do the other 50%. authDNS we introduced recently, I think about a year ago or so, and there we have a total of 7 instances, and since the last RIPE meeting we got 3 more, one in Salzburg, Sarajevo and Yerevan. Traffic statistics look like this. They're covering 10% of the total query rate. So to do the math, we are seeing about 120,000 to 160,000 queries per second. Those that want to do about 10% of that. Next one, DNS Sec. We decided to switch to a combined signing key, and the reason for that is The split of a KSK and a ZSK is just more moving parts. Reason for that is the both keys were stored together on the signer. So if one key is compromised, automatically the other one would be considered compromised as well. So there's no point in doing that. The other thing is, since we did an algorithm roll to algorithm 13, the key size is the same. Previously, we had algorithm 8 with, especially this ZSK had an RSA 1024 key size, where common wisdom is you need to actually roll these quite fast. Algorithm 13 gives a much better and stronger crypto, so we should be fine there as well. And so to switch to a combined signing key, you do a standard KSK rollover. The not DNS signer we use for this, it's just one config option, and then we tell it to please do KSK rollover. It goes ahead, does its magic. It waits for us to update the DS record in the parent, and well, this was a non-event, which in DNS Sec, it's a good thing to have that. It was really boring. Yeah, if you look at the zone, it looks like this. You will see that there's one DNS key that signs the DNS key R set, and it's the same key that assigns SOA as well as all the other records that are in there. A request from the community was to could you please lower the TTL on the NS delegation records and on the DS records? These used to be 2 days. We lowered the NS record to a day and the DS record to an hour. We did not see any spikes or increase in a query rate on the auth DNS cluster, and especially for the DS record, a very high TTL. If you're doing a normal KSK rollover, that's just annoying. If you have an event and you need to wait 2 times 2 days, that's really bad. So this should improve things. A software update. We're using a zone master to do a pre-delegation check. There's a new version out. We upgraded the version. You get bug fixes. You get a few minor additional checks. And what people really were waiting for was a support for algorithm 15 and 16. This is ED 25519 and ED 448. So we have support for that now. So have you recently disabled IPv4 on something? We did. Reason for that was we were actually running out of space on management interfaces on one side, and we looked at this. So how can we solve this? Oh, we could VPN and we could run this on private space. No, hang on, there's IPv6. Let's do that. And well, it just works. Except in some sites where we only have v4 and we need to poke people, or where v4 is actually better than v6. We need to work on that as well. But the idea is let's just switch as much as we can on the management interface to v6. We're a bit late on hardware replacement. Basically, we can't get the hardware in. We have been promised stuff will show up in June. Yes, this year. So we hope to be able to roll this out actually this year. These are the K-root core sites in Frankfurt and Miami. And another project that we're working on is AuthDNS has 3 core sites. They're all in Europe. We wanted to put in a 4th site where we will also face the issue of we actually need to get the hardware in. This says we aim to do this by the end of 2022. I'm a bit more of a pessimist, so I think it will be slightly delayed, but we're working on that. And I think this is actually the last slide. We try to be diverse in the software that we're running. So all our name servers, we're using a mix of bind, NOT, and NSD. We had some diversity in our routing software as well, which was BERT and ExaBGP for many years. We dropped ExaBGP, and we were running on BERT for a long time. To add to the diversity, we now also added FRR to the mix. And we need to do an OS update because CentOS is end of life soon. And I don't know if you have time for questions.
You were very quick, thank you. So then we have some time for questions. No questions, I believe. So then we have a small surprise still. So Shane, the floor is yours.
Yeah, so a little bird told me recently that he was doing some archive work, archaeology, looking into the historical record, and it turns out that in June next month, the DNS working group is going to be 30 years old. So we figured we'd have a little birthday celebration. We have some cake over here. Happy birthday, everyone.
Thank you. See you next time.
Well, welcome everybody to the cooperation working group session. Pretty packed session, I have to say. So I'm actually not going to bother with the usual administrative trivia because we have an email list for that. I do encourage you all to use the email list. It's been surprisingly quiet there considering everything that's going on. We have a challenging situation with the hybrid meetings where we have some panelists virtual, some panelists are physical, some presenters here and some not. And same thing with us chairs. We have Desiree, fortunately here after some challenges. We have me here and we have Achilles online. So we kind of balance that too. So we have two main topics for this session. And the first one is about network neutrality. And it's going to be a heated subject. So the best way to deal with that we thought was a panel. So we have some panelists to discuss that. And then we have a very last minute presentation on a topic that popped up on our radar suddenly. And when we saw it, we went, what the, which is the European Commission proposal for child protection. And yes, we all know what that means. So let me get things rolling and start with our panel discussion. And Desiree will moderate the panel for us. And maybe, do you want to introduce the speakers as you start, as your stage is yours. Thank you.
Thank you, Yulf. It's good then to see everyone in person and online. Let's start with the panel. Thank you, Yulf, for introducing it. My name is Desiree Milosevic. I'm one of the co-chairs, and we have Achilles also online with us who cannot be here in person. As Yulf has been saying, we have a panel on net neutrality, so I would kindly ask all the panelists who are here in the room in person with us to take their chair here and come up to the floor. And also we have two panelists online who will be joining us, one or two, we'll figure it out. So what we try to do is really have a diverse view on this burning topic on network imbalances, maybe. And we'll hear more from the esteemed panelists. As they're doing introductions, I will just briefly say who we have here in case you didn't read our mailing list. So we have with us today Marit Palvorita, and she's a senior director at Etno. We will also have two online panelists, Frode Sorensen and Klaus Niemann, who are both been working as the Open Internet Working Group chairs of the BEREC, which is the regulatory agency, as you know, for electronic communications. And also here with us, we have Alex Diode from AMP6. Hello. Our member. We have Thomas Loninger with Epic Center Works, who will be speaking to us about from civil society point of view on this topic. And we have Freddie Kunzler from Init7. So with that, without further ado, I would like to give the floor to Marit to see whether she'd like to start first with her opening statement.
Thank you, Desiree. So thank you for the introductions and thank you for the invitation to this event. I am very aware that this is, of course, a technical event at large, and the topic that we're discussing today is a policy topic, and even worse, a political topic, which probably will cause some controversy. And I think that's welcome. And in fact, the reason why I'm also here is because we, from the telco side, we wanted to have an open discussion on this because there is some bad history. There are all kinds of preconceptions. So we would like to, have this discussion this time around openly, and also to make sure that it's fact-based from all sides. So I think the title of this event says it all, a call for large content platforms to contribute to the cost of European digital infrastructure that carries their services. That's the session title today. And just to give a bit of background from Brussels, so I'm actually from ETNO, presenting the large operators, 33 of the largest operators in Europe, the former incumbents, if you like. And the discussion started last year. There was some calls from operators' sides on this topic, and the European Commission actually picked it up last year in a document that it's called the European Digital Principles document. And in that, they recognize that there should be some adequate frameworks to provide for a contribution or fair contribution to the infrastructures, digital infrastructures in Europe. And this was, of course, from our point of view, first time that something has been recognized in writing. And we then commissioned a report on this topic with Axon partners. There's a couple of copies in the front, because we wanted to really have a, let's say, an explanation on what is the problem from our side, where is the issue, what is the challenge for telecom operators. Also look at the bigger picture, what are the socio-economic impacts on this current situation on the European citizen, on innovation, on the green factor, which is very relevant today. And then finally look at lightly some policy solutions. So the report was launched a couple of weeks ago, and we've had a huge reaction to this from the highest political level to, of course, to the grassroots level from all sides. And what is the report about then? So, as I said, so we wanted to contribute to this discussion that the European Commission in a way opened. And it's really then to try and highlight on where are we today. So if I just give you some numbers, so the European telcos have invested some 500 billion euros on infrastructure in the last 10 years. That's a lot of money. And you know, that's also a lot of progress, I think, for the European connectivity. In the same time, data traffic volumes have also increased exponentially. And according to this study, so 55% of the current data volumes actually come from 6 players, you know, that belong to the so-called big tech or OTT, so whatever you want to call these companies. And that then is challenging for operators from mainly 2 perspectives. So there is, of course, a cost to delivering this traffic to operators, and there seems to be, at the IP markets level, an imbalance in the negotiation power at the purely commercial level of trying to come to an agreement on which terms and so forth operators can or should deliver this traffic. Of course, we all know that in the European Union we have the net neutrality rules, whereby operators are obliged to deliver all traffic to end users in Europe. So there's absolutely no way of saying, oh, we can't do that. So that's a kind of a red line, if you like. The other thing is the asymmetry in regulatory obligations. So as I already said, open internet rules have been, they weren't actually here in 2012. They have come along since. These are rules that are not, for example, in place anymore in the US. We have consumer price regulations still indirectly and directly in place in wholesale markets, partially also consumer markets. And finally, we have a competition policy framework in Europe, which pretty much makes it very difficult for the telco sector to consolidate, leading to a situation where we now in Europe have about 100 operators in a market that is, well, in some places not very populated. So that's the big picture, the problem, if you like. And then going to the solution, perhaps. So what are we looking at? At this stage, we are really wanting to understand better the imbalances in the IP traffic markets. And that seems to be the cornerstone of the discussion, also from our members' perspective. What is also clear, and we wanted to put it up front there in our report, in this report, that anything that we do should be done by respecting the open internet rules that we have in place. And this may sound a bit light coming from the operators, but in fact, in the past few years that the regulation has been in place, this has become a kind of factor of stability for our members. So now that the practices have been established, And in fact, there are very few, let's say, violations of the rules these days in Europe, so they are very well respected. So, you know, that wouldn't be the instinct to go that way and try and change the regulatory scene that way. So the only then solution is to, as I said already, to try and address the perceived imbalance in power, in market power in the IP markets, and to see a little bit on if there should be some kind of a fair contribution to the network deployment by those companies who are generating most of this traffic. So maybe I'll just leave it there, just to say that, as I said, so, you know, it is a divisive issue, and we are here to have an open discussion. So I, of course, then welcome questions and comments from the audience.
Thank you so much, Marit. I'm sure that we will get a lot of questions for you and responses. I would maybe ask Alex, since you're sitting next to give your perspective from M6 and from operators' point of view.
Thank you. I've been working in the Brussels arena for the last, I think, 10 years. And when I started, this also was a discussion. So basically, we're redoing the discussion that happened 10 years ago. I think in one of the coming presentations, there will be an outlay of what the history was. Sufficient for me to say that in the end, Commissioner Kroes said that the reason people pay for internet connectivity is these big platforms. So they provide a service where the telcos basically can sell the internet connectivity for. One of the questions you then of course have is, why are they redoing this discussion now? If you remember, there was a discussion a couple of years ago about Google and Facebook publishing news articles. The publishers wanted to have a slice of money from that. They lobbied in Brussels and successfully, and Google and Facebook now have to pay publishers for news snippets. I think you have to see this ethno action in the same light. For Brussels, big American technology companies are bad. European companies are okay. So if you want to get some extra money as a European entity, it's very easy to stir the anti-American sentiment in the Brussels policy arena. And I think that's what ethno is doing. One of the tenets, I think, of the internet we have now is that everybody pays his own cost. So you have a network, you pay for your cost. Already you have to pay extra if you want to connect to the eyeballs. You can get very cheap transit for 10, 6, whatever cents per Mbit. But if you want to reach one of the bigger telcos, you have to pay 40, 50 cents, which already is 4 or 5 times what you pay for normal internet. So they already have toll gates available. They're not on the main IXPs anymore, because then you have to exchange traffic for free. You can't use your toll gate. So in effect, they're having their customers pay for the internet connectivity. They upgrade it every once in a while, so you pay a huge amount relatively for the usage. And now they're saying, people are making use of a lot of these American platforms. Apparently they generate 60% of our traffic. So let's see if we can get some extra money. I don't think that's the right way to do business, but we can have the discussion later on.
Thank you. Thank you for sharing your views with us, Alex. I think before going online, I would just ask Thomas to maybe react to this business perspective. If he, as a user, has a point of view of how would this possible change affect internet user.
Thank you, Desiree, and thank you for the invitation. I'm very, very happy to be here at RIPE and also here in a room with you all. It was mentioned before that this idea that we are discussing today is actually very old. It is as old as the telephony network, because the termination fees that we know there are basically what ethno is proposing. And this idea that keeping a customer reachable and therefore deserving money from whoever wants to communicate with them is the core of this idea. It was called calling party network pace, and this time around it is called sending party pace or sending party network pace. And it was discussed at length 10 years ago at the ITU level and rejected almost unanimously. The OECD thought it to be unworkable. BEREC, the body of telecom regulators in Europe, rejected it outright. Since commissioned studies on interconnection, several of them, they all came to the same conclusion, and those guys have access to the full picture of the market because they are regulators. They are allowed to look deep into things. I'm not even mentioning the case-by-case assessment that we've seen in France, in Germany, and all of these independent actors came to the conclusion, no, there actually is no problem. And the whole basis under which this proposal comes to us is based on a flawed understanding of how the internet works. If you go to the statements of Commissioner Vestager and Commissioner Breton, they are talking about the traffic being produced in the network by these big tech companies from the US. So they are just have not understand that this traffic is requested by paying customers. And this is thankfully how the internet works. And you can assess here also that we are talking about a fundamental shift. We have seen only one country in the world where this has succeeded. It's South Korea. They have a sending party pace system. And the consequences there, I would invite you to scrutinize them. If Europe were to follow this model, that would be it for the global interconnection market. Because the subsidiaries and the market power and the global standard setting function that Europe has would lead to a global change in the way we connect the internet together. And ETNO talks in its study about an obligation for OTTs to negotiate direct agreements with the telecom companies. One has to ask, what else? Like when I have to negotiate an agreement, what happens if I don't reach an agreement? Because these right now are secret business deals. Most of them are not even open. So what happens with the transit? What happens with all of the other connections that are not part of this paid peering agreement? And I come back here to the declaration that ETNO is basing its lobby attack on, the Declaration about the Digital Decade. There it also says we commit to protecting net neutrality and the open internet. And content services and applications should not unjustifiably be blocked or degraded. And again, coming from someone like me who has been working on net neutrality for over a decade, it's great to hear the telecom industry talking about stability in the market. We've been fighting against zero rating for many, many years. And it was just last year that the European High Court sided with us and said, no, zero rating is illegal. And now in all but 2 European countries, we have to scrap the zero rating products because they are everywhere. And we've conducted a study in 2019 and looked at the applications that are zero rated. From the top 20, only 4 are from Europe. All the others are Americans. So the telecom industry cannot, via zero rating, incentivize the traffic from the big American corporations. And basically, they've given it for free. It was not even deducted from the monthly data cap. And at the same time say, oh, but they are flooding our networks and now we want money for it. There is a net neutrality law in Europe, thankfully. The Telecom Single Market Regulation has a clear obligation. The telecom companies have to connect to all endpoints of the internet, that they have to treat all traffic equally, technically and commercially, and they are not allowed to change the price of their products based on the applications that are used. So for me, it is clear, if ETNO wants to succeed with this, they have to scrap net neutrality from the books. We have to reopen telecom single market. We have to basically, there's only one historical example from the Donald Trump administration, completely destroy net neutrality protections in Europe for the ETNO proposal to be remotely legal. And lastly, I want to use this opportunity to invite you all to join the debate. This has been going on, as we've heard, since last year. And believe it or not, this is the first public debate that we had about this. We've tried to come into the closed-door lobby meetings that have happened in Brussels, so far without success. Civil society was not on the table. And you as a technical community that will have to live in this new regulatory framework were also not on the table. So I would welcome you all to join the debate, to help us make the case for the open internet, and to hopefully prevent this ETNO proposal from becoming a reality. Thank you.
Thank you, Thomas, for your views on that. We'll go further and back to Freddie Kunzler from Init7, who has prepared a short set of slides. So if we can just have them online. You have your own opening statement. You can probably say next slide.
Okay, I say next slide. So thanks for the invitation to this roundtable. My name is Freddie Kunzler. I tried to shorten the long title that it fits my slide. So GovOn to pay for FTTH. This is the goal, basically. Thank you. I don't know. It doesn't work. Maybe I'm too stupid to press the right button.
Green is forward, top one.
Oh, now. So short word about Init7. Oops, now I'm one back. This is me. I'm CEO and founder and network engineer at Init7. Init7 is an independent broadband provider in Switzerland. We do gigabit FTTH since 2014. We recently launched 25 gigabit FTTH because it's cool, same price, includes TV. And we aim to provide a broadband service which is not broken, unlike many others. And if you're interested in what we do, see the archive of my colleague Pascal Glor, our CTO. He presented yesterday in the Connect working group. We also won some awards. And now to the topic GovOn to pay for FTTH. So here I had a slide in between. It said just no. Because broadband customers, they are causing the traffic and not content. And this is the big misconception of Marit we had before. Content is not producing traffic. That's simply not true. The traffic is requested by the end customer. Despite of the asymmetric traffic flow from content towards eyeballs, the traffic is still requested by the broadband customer. There is one exception, that's email, but that doesn't count because that's below noise level. The principle calling party pays has been reverted by the incumbents to sending party pays. And the eyeball provided incumbents, they can enforce that due to their technical monopoly. And I have here this drawing, that graphic was produced a couple of years ago by the company formerly known as Level 3. Actual name might change in a few months again, but never mind. So the yellow points are important because these yellow points are the gatekeepers. So you have the angry guy preventing you to enter the club unless you pay high. And that's technical monopoly that allows incumbents to enforce the double-sided payment for broadband customers and from content for at least a decade. And that's simply illegal because it's an abuse of the technical monopoly. These same incumbents, they expect additional contribution from content providers to build out FTTH infrastructure, fiber, etc., etc. So my opinion, the incumbents, they're whining at Mrs. Vestager, and it's so pathetic because, I mean, they really have a miserable life. Not sure whether you can see that, but these are the figures of Deutsche Telekom. And sorry, guys, they make big money, and I don't know why they want their rich neighbor to pay additional to contribute to their money they make every day.
So now, having seen no questions online, we're going to go back to our online presenters, and I would like to ask Frode Sorensen to come up first and give us his point of view, since he's been working as an open Internet Working Group chair since 2012. The floor is yours.
Thank you.
And we can hear you well. Welcome.
Very good. Thank you for the invitation. I represent the Norwegian regulator, the so-called Norwegian Communications Authority. And I expect I'm invited due to my background as chair of the BEREC Net Neutrality Working Group 10 years ago. And as you can see on the title of my presentation, I will try to look into the current discussion based on a paper from BEREC in 2012, developed while I was co-chair of the working group. I'm one of the authors of the document, but it's also a document approved by BEREC, so it also represents principles that are well understood by telecoms regulators. I think that's sufficient about my background, and I can skip to the next slide, please.
Since you're controlling the
Is
slides,
it possible for me to
scroll it further?
Okay. Yes. As you can see, the slide is separated into 4 pieces. It was supposed to be an animation, but anyway, regarding the first 2 bullet points, the main content of the document is a discussion about the charging principle sending party network pays. It's been mentioned by other panelists already, and the reason for discussing this topic in this paper is the similarity between the current discussion about charging on the internet and the traditional charging in telephony networks. In telephony networks, prices are regulated still, and it has been for many years. And the main problem which is remaining regarding telephony regulation is that when you place a telephony call to an end user, you must pass the telephony provider. The telephony provider thereby has a monopoly of the call, and therefore it's a possibility for this provider to raise the charge to a higher level than what is the optimum price for the market. And therefore telephony regulators still regulate the telephony operators. And the danger that BEREC saw in 2012, and which might also be the problem this year, is that if internet traffic is charged by the receiving network because the sending network sends a lot of traffic, then there might also this time be a need to regulate the agreement between the sending and receiving party in the network. Another point that was important to this paper from BEREC, as you can see on the next 2 bullet points, is that there is a dependency between the ISP and the content provider, because the ISP can't sell his access without any content. And on the other hand, of course, also the content will not reach the receiver without a connection. So therefore, it's important also for the ISP that the content is distributed over the internet. So the content itself is also a value that is important for the ISP. And related to that, as has also been pointed out already in this discussion, it's the end user that requests the content. And the end user pays for the transfer of the content already. So that's in traditional, the traditional way of working of the internet, the ISP is receiving his income from his own end users. And finally, in this BEREC paper, the conclusion is that this model has enabled high level of innovation, growth of internet connectivity, and development of a vast array of content and applications to the ultimate benefit of the end users. Attempt to undermine this could put this benefit at risk. So the goal for this view, the reason for this view from BEREC is that we still need to maintain this innovative power of the internet. And it's, of course, mainly due to the small and then the upcoming content providers, application providers, that this is important. This is not to protect the big content providers, of course. The main reason for this is to protect the smaller providers. Taking a brief look at 2022, things have changed. The traffic is increasing. That's actually nothing new. It has been increasing all the time on the internet. But of course, as we all know, the big gatekeepers, the big content providers, they have become even bigger for the last 10 years. But this is also the reason for new regulation that is introduced in Europe, like the Digital Markets Act. So steps are taken already to take this into account. Furthermore, related to that, BEREC is also publishing a report on the internet ecosystem in a couple of weeks, which will also discuss the relationship between ISPs and content providers, which might also shed some light on this, this discussion. These principles from this paper 10 years ago should still be valid in our understanding. And I will afterwards leave the rest of the BEREC discussion to my colleague Klaus Nieminen, who is the current chair of the working group. Thanks.
Thank you very much, Frode. And Klaus, if you're online, please take the floor.
Okay, good afternoon, everybody, and it's my pleasure to be here. I'm Klaus Nieminen, a co-chair for the Open Internet Working Group, and basically been working with the net neutrality and also with the IP interconnection for around 20 years now. I'm normally working in Traficom, that's the Finnish telco regulator, and I'm acting as a chief expert there. Maybe a couple of points first on this topic. I think the motivation, of course, and the one of the ideas what also was presented by Etno was that we want to see the gigabit society targets to be met, and that of course we all agree that we would like to get a good broadband connectivity for everybody in Europe. But the question is that whether there is a fairness issue around this topic. I think we've been hearing from the Commission that they've been investigating the matter, and I think it's also mentioned by the Commission that well, they would look into the question whether there's a fairness issue or not. From BEREC point of view, I would say that we consider this matter very important. I mean, we are very happy to see how the internet has evolved, and basically it has been allowed the internet ecosystem to grow and also provide innovations. And of course, we would like to see the internet also to continue in that manner. Now, well, just actually agreed because I'm in Dublin in BEREC meeting, and we just agreed that we are studying this topic too. We want to give our contribution for the discussion, but the discussion is just starting in BEREC. So basically, I'm not really going to give you any insights on what the outcomes will be, but I can promise that you will hear from us in the near future around this topic. And basically, I would also like to mention that we are seeing that there are actually plenty of different contributions already available. I think for example, the weak consultant study conducted for BNetzA, the German regulator, was very helpful. Also to recap the interconnection ecosystem and how it works at the moment. We are seeing that there's also contributions for this specific fair share topic. We have seen the contribution from Etno, But we also received one contribution from ISPs regarding this topic for the Open Internet Guidelines, and that will be published in June. Then we published the Open Internet Guidelines, but I would have to say that those ISPs were very critical for that proposal, the ETNO proposal, and also seeing that there are potential competition issues if that kind of the proposal would go through. We have, of course, the only example from South Korea, and I think we are also going to look to that use case, and definitely we believe that the end user and the impacts to the end users and to the competition need to be paid a lot of attention. So basically, we believe that whether somebody would make a clear proposal or to implement this fair share, so we must make sure that also these aspects are properly evaluated. And I think from my point of view, I see that it's not going to be a clear cut. I mean, we see also from the industry and from the ISPs that yes, there's a certain ISPs supporting this and also some other ISPs very much opposing it. So to me, the landscape is already quite a split in that manner. And maybe to conclude, I would say that really the fairness is also something I would like to maybe put as a question. Basically, then we talk if there's a fairness issue, what do we mean by the fairness with this regard? I mean, the big telcos were talking about a lot about the traffic asymmetry. But if you think about, for example, the small eyeball ISPs, to me, their traffic is very asymmetric because they have only the customers consuming the content, and basically it's not really that much symmetric to the traffic at all. But that was basically maybe my remark that I would like to get the good discussion. I would like to see a lot of let's say contributions and also this topic to evaluate it from different angles. So we would have a let's say good contribution also for the political discussion. Thanks.
Thank you very much, Klaus. We'll now go back to, before we open up the floor, back to the panelists here in person, and maybe who would like to make further comments. Marit, you have the floor should you wish to respond to some of the things.
Well, there were so many comments, to be quite honest, that I don't know where to start. Yeah, maybe on the net neutrality point that Thomas brought up. So because I explicitly said that we have excluded this from the consideration, and so I wouldn't want to be dragging it back into the discussion because, and then maybe Klaus and Freude can correct me, but interconnection is outside the net neutrality rules, the open internet rules. As we speak today, and I may be wrong, but I would be happy to be corrected if that's not the case. So we don't see it as an issue of net neutrality as such, as I already said. So from our point of view, there's no need to, let's say, revisit that side at this stage. Of course, we are aware that open internet rules are likely to be reviewed, or at least there will be an assessment in the coming year or two. So that's then another opportunity to discuss this, and there will be certainly many other stakeholders who will be contributing to that discussion as well. About the points on openness and transparency on discussion, I would just like to also say that this is not the first public event that we're discussing it. We had 2 events this week in Brussels. And also the shady meetings behind the doors. I mean, we've been doing very proactive outreach bilaterally to stakeholders, including EDRI. This is truly an issue where we would like to also collect inputs, because also the solution, as you have heard, is not very clear. And it's also a very European situation. So the regulatory framework in Europe is quite tight for the telecom operators, and tighter than in other parts of the world. So it doesn't leave a lot of room for maneuver to find alternative solutions, if you like. So, well, I don't know if there are further questions on specific points, but I would leave that there. Just to echo Klaus, maybe that, you know, we have now the very ambitious targets in Europe the political targets, fiber and 5G to everybody by 2030. And if we want to be serious about this, the current financial state of the European telco sector simply doesn't allow it. And I appreciate that there were some nice numbers being showed, but DT, for example, has a very successful operation in the US that is doing much better, and mainly because of the regulatory differences between the US and Europe. And hence, for example, it can be argued that 5G deployment in US is much further ahead than in Europe because of these investment issues. And I'm happy to provide numbers if that's of interest, but also I understand that this is not the financial community, so I will perhaps not go there. Thank you.
Thank you, Merit. I'm sure people are taking notes as you speak and waiting for their comments, but we also would like to open this round table to people here in the room. So please, there is a roving mic here, and come up to the microphone if you have a specific question to any of the panelists. Thank you. Anyone wanted to make a point? Thomas, you?
Yeah, just to clarify. So such access fees or sending party pays are clearly illegal in the 2010 and 2015 Open Internet Order of the FCC in the United States. Of course, those have been scrapped by the Trump administration, but the California and New York net neutrality law would still prohibit this. Similarly, in India, the net neutrality framework would prohibit this, and I point you to paragraph 5 and 6 of the BEREC net neutrality guidelines that clearly say that interconnection cannot be used as a circumvention tool for net neutrality protections. And circumvention, I think, is the right approach, because it would in fact mean that the traffic from certain CAPs is treated differently in the network, that it would be at a lower quality to the end user, and the pricing, of course, is also affected. Interconnection between access networks, of course, is out of the current net neutrality framework. We have a case-by-case provision there, as you know, in the EECC. And just lastly, because this money aspect, the ETNO study is quite vague on several fronts, but it is very concrete when it is talking about how the money should be used. And you are clearly excluding any taxation model or any fund-based model where we could have a democratic debate how these incomes should be used. So there is only one way that the telecom industry sees here the money should be used for them. And then lastly, there are studies that can show us that in the countries with the highest termination fees, you have the lowest network investment. So with all of this pile of evidence, also the aforementioned study from the German telecom regulator on interconnection in particular, that I think is quite recent. I think we need to take all the evidence into account when making policy.
Thank you, Thomas. I'm going to give the floor to an online person first, if you, unless this is a direct response. Patrick Tarpey has been waiting to make his question, and then, oh, okay, you're here.
Hello, I'm here in the room. Patrick Tarpey, Ofcom, that's the UK communications regulator. Just a couple of observations. Are you not concerned that if this plan were to go ahead, the unintended consequence would be that for smaller operators who don't have such great negotiating power by dint of the amount of eyeballs that they have or the size of their actual user base, could be seriously disadvantaged? So you may find an unintended consequence, maybe in the rural or other poorly served areas, will be have further detriment. And secondly, earlier today I mentioned the words oblivious technology and the ubiquity of encryption. And in fact, we see recently the deployment of Apple Private Relay has actually upended this notion that operators can plainly and clearly see the real destination and source of traffic that's flowing through their access network. So there's two kind of concerns I have immediately. And I want to emphasize this is not an official Ofcom view, it's me as an individual here. But as I say, it's one about competition size, negotiating power, and the other is the emergence of oblivious type encryption.
Thank you, Patrick. Would anyone like to make a comment on any of these two? Okay, thank you for your...
I completely concur, and I would like to have answers to those.
freelance consultant. I am not an operator, I am not an economist, so I clearly don't know what I'm talking about. I think Klaus made a very important point earlier on in the discussion about the word fair, because there will be many different interpretations of that. What's considered fair for an incumbent operator will be different to what a content provider thinks is fair, which will be different to what an IXP thinks is fair. So we have to be very careful in the use of the language for these kind of things, because these words can mean different things to different people, and it depends on the context in which being used. So I think an important part of the discussion that has to take place here is to have a common understanding of the terminology. Simply saying this is not fair, well, that may be your perception of it, but for another part of the market, any particular standard is more than fair, it's more than reasonable. And I think another important thing is we have to bear in mind that in this particular discussion about network neutrality, it's different a little bit from how it was like 10, 20 years ago when the previous discussions had, because the technology and the architecture of the internet has changed. Patrick was mentioning things about the bluest technologies and the ubiquitous uptake of encryption technologies. But there's also been some other work happening with actually delivery of content. Jeff Houston, who does a lot of research on this stuff, they've got some excellent talks. One which people look at is death of transit. And this basic thesis there is that the big content operators have their own global fiber network, and they're installing cache nodes, what we want to call them, inside the eyeball networks, so that the eyeball networks are not paying for the transit to get the content. All they're doing is distributing over their own internal network to the end user. So from that point of view, the costs are probably next to nil. I don't know, but I'm speculating that's the way they'll be. And I think that's a good consideration. So whenever an incumbent operator says 55% or 75% of our traffic is from these big six content providers, and much of that is actually coming into your network, and much of that traffic is actually being distributed within your network, and you're not actually paying for the transit to get content from Facebook or YouTube or whatever actually brought into your network. So I think we have to be very careful when we're talking also about traffic levels and traffic patterns. What do we mean by 55% of our traffic comes from these providers? Thanks.
Thank you, Jim. You said fair, not fear.
I think I can confirm that. I mean, we're talking about 80%, up to 80% of the traffic flows in from just 10 ASNs these days, and I disagree with the comment of Marit that she said it's a challenge for eyeball operators. That's not. It's actually easier if you just have to talk to a few to optimize a lot of traffic. And it doesn't cost a lot. I mean, we're just talking here about the cost of layer 3. And a typical eyeball, I don't know, I probably would spend €1 or €2 per subscriber a month for the IP part. And that's almost nothing compared to the total cost of providing a service. And to counter the agreement, saying that we're not talking net neutrality. I mean, don't we passively not upgrading is actually an aggressive act. And in my opinion, it's a violation of net neutrality. And last but not least, there is no lobby in Brussels for the end users. So what do they expect? They expect a service which is not broken. And what is not broken? Is it just okay that they don't call support, or is it, do we really want to provide a good service? Are we proud enough to provide a good internet service to our end customer? All these games, who is paying whom, etc., that's against my standards of being a proud network engineer to provide a good service to my end customer.
Maybe just an immediate reaction. Okay, yes, it's in theory easier to talk to a few companies, but what if they don't want to talk to you because you're too small? What if they do not want to have it?
They talk to me. Yesterday I had a meeting with the guys of Netflix. They bring me new cache service. So they talk to me. They want to provide a good service, and I help them. And we have a joint interest to provide a good service to our end customer.
Well, you probably have a privileged relationship there then.
No, definitely not. No.
So maybe just to there was a gentleman who was talking about the network level. So we do, of course, understand that there is that the big tech are investing in the global infrastructure, that they are bringing the content nearer to end customer. And I've been privileged actually to hear Jeff Huston's transit debt presentation in a RIPE meeting some years ago. And it's very eye-opening. So we're here really talking about the network layers from the CDN, from the cache to the end user. We're not talking about the global internet as such from our point of view.
Sorry, just 1 second. Frederick, Amazon Web Services, one of the big players here. We talk with everyone.
First give the floor to Alex and then...
If I may add to this, if the content provider puts caches within the network of the telco, whatever happens within the network of the telco is covered by net neutrality. So if you say we're going to do stuff with it, we want to get paid extra, etc., you're directly interfering with net neutrality. It's not like, okay, it's outside the border, it's transit, it's coming in, it's interconnection.
Well, I don't know, but maybe we have regulators online for a clear interpretation.
If anyone wants to make a comment from Klaus or Frode, please.
Well, if I may, basically, well, first of all, as mentioned already, well, we consider that for example, the interconnections are something that the NRS may look into, because I mean, even the commercial practices from ISP cannot circumvent the end user rights according to the free one, and also now, of course, the equal treatment obligation that covers also the pricing practices, and basically, well, I would say that we are not still stepping into the directly regulating the interconnections, but they are relevant in this context. That would be my answer, and then basically we haven't had that kind of the cases, I think, that many in the past, so that's just now where the Trafficom hat on, because it's not really a topic that's been let's say debated a lot within BEREC at the moment. Anything would like to add, Frode?
Yes, I agree with you, Klaus, and then I could also add that what is net neutrality? That's also a philosophical discussion, and it also depends on jurisdiction. So in our case, it's a question about what does the European Open Internet Regulation say about the question, and in that regard, it's very clear about the access leg of the service, and it's not very explicit about the interconnection leg. So it is covered to some extent, which Thomas referred to, but I also agree with Marit that it's not that obvious how interconnection should be regulated based on net neutrality. And that is also the reason why BEREC is not referring explicitly to net neutrality in the 2012 paper. It was discussed on a more general basis, based on, for example, the question about termination monopoly. But that's the current state. You never know what happens to the regulation. So, of course, it could change in the future. And I believe it's also more explicitly covered in, for example, the former US regulation and the Indian regulation, but not that explicitly in the European regulation as far as I can understand. Thanks.
Thank you for both the clarification. We go back to the line. Please say your name. And
Partner Maya from LACNIC, speaking by myself. Not properly a question, but perspective from our region. We have a reality totally different from Europe, and we have nowadays 16,000 ISPs, small ISPs. All those ISPs are deploying fiber, FTTH, with their own network, their own fiber. At least each small city in Brazil, at least one ISP is present in the city. And I think this reality was due to a lot of things together. First, our internet governance model that was created in 1995 and is present until today. And a law that's called the Marco Civil. This is a law, important law that respects net neutrality, and mainly by the poor interest of the big companies to provide service in the remote locations. Because if we are expecting from the big companies to provide, maybe we are in the last century.
Thank you for that point of view from Latin America. Well done.
Blake Willis, Peering Geek, just speaking for myself. The internet has consistently proven itself to not really care too much about national political borders. And we already see this in content markets where, for example, France, where I live, there are certain media companies that have monopolies on certain media properties. And so many streaming companies simply serve traffic into that market from other EU markets, thus completely avoiding the French content monopoly on whatever content it is. If in a hypothetical future where the European Union has member states implement a sender pays model, would that not simply shift the interconnection market for European traffic to nearby markets that do not need to do such things, such as the UK?
Anyone?
Anyway, that's really more of a question to the organizations pushing for this sort of legislation.
In Switzerland,
there
are
push it out of the
bunch of data centers. Yeah, you can rent space and connection.
Does Marit, does Etno have a view on that?
Listen, so I mean, there were some comments on the Axon paper, which is not an Etno paper, it's an Axon paper, and the policy options. And I think that it's very clear that the policy chapter, first of all, is very short. So it is not a lengthy policy analysis of the options that should be considered. It is a kind of shallow list of options at this stage. What could be options to address this issue in the wider, not only in the interconnection sphere, but in the wider policy context in Europe, whereby we have these network investment objectives. So the purpose of this paper was never to conclude and say, listen, this is what we want, or this is what we don't want, etc., etc. It is to put some options out there for discussion, and then to debate what are the potential positive consequences, and then the no doubt unintended negative consequences that would be the result of it. So we're not there yet. And also there was a comment about what would be fair and what would not be fair. This is not, we don't see that this is something for us to decide. This is something for the policymakers. As we said, this is a policy issue. It is something for the policymakers to look at as well and to decide. First of all, is there a problem? And then if there seems to be a fairness issue, well, what would be fair? So I don't think that, operators would step in and say, well, this or that. Similarly, for the policy options, we have a very, very tightly knit regulatory and policy kind of network in Europe. So there will be, if there will be every time there will be new pieces of law, there are always consequences. So this should be, of course, very carefully analyzed.
Thank you.
Hello, I'm Thorsten Sommer. I'm here at my first RIPE meeting, and I'm a bit nervous right now. I speak only for myself. Also, Arbonne has sponsored me for being here. I have a big background in politics. So after hearing all that discussion right now, it sounds a bit to me, it's not just about commercial stuff. For me, it sounds like controlling a market in first step. it sounds a bit like who's deciding who can enter that market after all. And if the big companies can decide this in Europe, if a small company can enter the market, if they can afford it, maybe then those big companies only stay by themselves. And that's just the first step, because who owns these big companies in Europe? The big telcos, or most of them, are owned by governments, by states in Europe, the biggest. For example, the Telekom Deutsche. So what's the second step in that? If you control the market and have every control of all that stuff, what would be the second step to control the content? So this discussion is not just about who's entering the market and stuff. It's just the first step discussion, just for me. So maybe what's your, I would like to hear what's your thought of that statement. Thank you.
If anyone is thinking whether content is controlled.
I have an opinion on that. The point is, if we look at from the client's perspective, who is the client of an incumbent? Is it the customer, the broadband customer, or is it the shareholder? And I believe it's the shareholder. And this whole discussion is only about how incumbents can protect their revenue streams for the shareholder. That's the only point. And it's not about broadband. It's just that's the horse we're riding on, but it's only about the profit of the incumbents.
Thank you. We're getting close to the end of time, but we can still extend for one more question if there is one question, burning one. Online, we don't have any, nor in the audience. But I think it would be really nice to hear from everyone who's here. What do they think is the next step going forward? Because there seemed to be some kind of exclusion in the regulation where the interconnection charges are part of net neutrality, and whether that's part of a broader, and what would these experts and regulators suggest? Where does technical community go and participate further in this discussion? So we can start from maybe people online, maybe first Frode and then Klaus, and then go from Fred back to Marit.
If I may. Well, basically, as I said already in the beginning, my understanding is that the Commission is at the moment studying the topic, and we might get then something out of them. So basically, we are not, of course, sure what the Commission potential proposal would be. And basically, as I also mentioned, that as a BEREC, we also like to contribute to that discussion, and basically, I think we would be getting some publications in the near future. But basically, yes, the next steps are still, let's say, a bit unsure to me on two different levels. Of course, what the time scale would be. So the when we would have any concrete proposals, if we are going to have them, and secondly also, I mean, what will be proposed and what kind of the tools would be then used to implement them. So basically, I think we are in a very early phase of this discussion, and as far as I understand it, well, there's not that much to conclude yet.
Thank you. Frode, if you'd like to go next, if you're still with us.
I agree with Klaus that we still don't know exactly what should be the next step related to net neutrality. I think we have to study the current situation in detail. After all, it's 10 years ago since the previous statement from BEREC related to this specific topic. But furthermore, we also have the net neutrality regulation, which was not present in 2012. So this is, of course, an opportunity to see the two things in connection with each other. And I think it's also relevant to refer to other BEREC activities related to the internet ecosystem. BEREC is currently studying these topics on a general level, and as I mentioned previously, we will launch a report for public consultation in the middle of June, and there is also upcoming work streams for the next year related to other aspects of the internet, not only net neutrality, but to look into the internet ecosystem at a more general, with a more general approach. Thanks.
Our request that the Swiss regulator to regulate the IP interconnection on a cost-oriented basis is now pending for 9 years. I hope it won't go another 9 years until we have a result. We have proven with a study of WIC, some of you might know this institute WIC, that the cost, the true cost of interconnection is zero. And so zero settlement peering would be the result, and we want that regulated. And I don't know how much impact it would have to the European market if the Swiss regulate this, but certainly it would be attractive for content to host the content then in Switzerland and push to Europe then. So as we are in the middle of Europe, but not part of Europe.
Thank you. So as I mentioned earlier, I'm very happy that we have this debate today here, and I think it should be a starting point, because right now I can only tell you that what happens in Brussels is quite isolated from arguments. And it really requires the insight of practitioners like you here in the room to inform politicians. Commissioner Thierry Breton announced that the Commission will move on this probably with binding legislation later this year. Of course, this could be postponed. It could be the next term. We have the review of the net neutrality framework coming up next year, but this danger is real. If you believe it's too stupid and politicians would never do this, I refer to the next session on chat control, on the direct attack on end-to-end encryption. We have to acknowledge the reality that arguments that seem very simple to us are not common sense somewhere else. And so this transfer of knowledge, this making our own voices and our expertise heard in the Brussels community is the big task that lies ahead of us all if we want to prevent this. And here, wearing my AG board hat for European digital rights, would be very happy as civil society to also engage with RIPE, with other communities, to make the politicians understand what the true consequence of such proposals would be. And that's also why I'm here, and I'm very easy to talk to. I'm also very easy to find online, and I hope we can take it from here. Thank you.
Yeah, I fully agree. Ethno has been working behind the curtains. This popped up a week ago. It means that we can't wait. There are a lot of people here in the room. Hopefully you care. Maybe we can do something with RIPE. Maybe you're a member of a local association. So please see what you can do. In the end of the year, most likely Breton will want to have something to show. It most likely will not be good for what we consider the internet. So if you feel that this is a real threat, you have resources, make sure you go to Brussels and you pitch the SME, small, medium-sized enterprises angle. That's what Brussels really likes to support. Innovation, that's something they would like to support. Don't tell them that you're American big tech. They really don't like you. You have your own lobbyist in Brussels. You will do the fight also. But please try to find some coalition. We're here. We're willing to help. Thank you.
So my understanding is very much the same as that of Klaus. So the European Commission has publicly said that they're working on it. They're looking for data. I'm not sure if it will be studies or other things. But like yourselves, we are also waiting for further feedback from that side and expecting, I guess, that there will be further discussions on this topic in the coming months.
Thank you very much. And with that, before Chris, you have something burning to
Sorry,
say?
I know we're running low on time. I wanted to say first, thank you all for the speakers who've been here. I know it was a very big panel, but I think it was really valuable. Sorry, Chris Buckridge, RIPE and CC. It was a very big panel, but it was really valuable to have all those different perspectives. And thank you, Desiree, for moderating that. And that's obviously a challenge too. I also particularly just wanted to say thank you for Marit for stepping into the lion's den in this way. I think, yeah, it would have been a much poorer discussion without the ETNO perception. So
thank you, Chris. Thank you, Chris. And thanks for all the attention. I'm just also doing my job. So thanks.
So with big applause to our panelists, I'll pass it back to Yul for our next speaker online. Thank you all. And a big round of applause.
Have a good luck with that. Thank you, Desiree. That was a great panel. So, yes, as you heard, if you thought these ideas were crazy, wait until you hear the next presentation. We have Konstantinos Komatis talking about an interesting proposal from the EU. Go ahead. Thank you.
Hi, everyone. Thank you very much, Yulf. So some more good news, apparently, coming from Europe. For those of you who are familiar, Europe has been working for quite some time now, the European Commission, better yet, has been working for quite some time now on a proposal for this sexual child abuse, the exploitation of children. And this proposal has actually been postponed quite a few times. And in the beginning of the week, the Commission finally dropped it. And a bunch of us have been reading in and trying to absorb the extent of what the Commission is proposing. So being conscious of time, I have been asked by Yulf to provide a high-level assessment, or better yet, a high-level analysis of what this proposal is all about. So in a nutshell, the essence of the proposal is that Europe wants to scan all of your WhatsApp photos, iMessage texts, and Snapchat to check for child sexual abuse images and videos. Of course, you know that better than me, this would directly affect and most probably will undermine end-to-end encryption, especially given the fact that most of these services support, of course, end-to-end encrypted communications. The proposal has various things, includes various things. It recommends the creation of a new EU center to deal with child abuse content and introduces obligations to companies to detect, report, block, or remove CSAM from their platforms. At the same time, tech companies, and this can range from web hosting services to messaging platforms, can be ordered to detect both new and previously discovered CSAM material, as well as potential instances of grooming. And on top of that, the detection could take place in chat messages, files uploaded to online services, or on websites that host abusive material. For those of you who have been following the debate on CSAM, this proposal is very similar to what Apple tried to do last year, quite unsuccessfully, after a huge backlash from both security, privacy, and civil society experts. Now, if passed, the EU legislation would require tech companies to conduct risk assessments for their services to assess the levels of CSAM on their platforms and their existing prevention measures. If necessary, regulators or courts may then issue detection orders that instruct technology companies to install and operate technologies to detect CSAM. These detection orders would be issued for specific periods of time. The draft legislation does not specify what technologies must be installed or how they will operate, but it says that these will be vetted by the EU Abuse Center and should be used as per proposal, according to the proposal, even when end-to-end encryption is in place. And I think that here is the crux of the issue. In discussions that I had with some people in the Commission while this was cooking, the Commission really understands well the impossible task of having it both ways, but it really seems that it doesn't care. And their response seems to be, if someone reads the proposal, this is not our problem, and tech companies need to circle the square. Now, in terms of implementation, there is only one logical way to go about this, and that is client-side scanning, where the content is examined when decrypted on the user's device for them to view or read. So by imposing a mandatory monitor requirement for all online communications and effectively outlawing end-to-end encrypted services, the proposal would violate children's fundamental rights, including the rights to respect for privacy, including communications confidentiality, the protection of personal data, freedom of expression and information, and the integrity of the person. So it is quite ironic that the proposal would violate the very rights of children that it actually seeks to protect. Now, the role of encryption in protecting children's fundamental rights has been debated over the years, and of course it's not new, but it has also been recognized by organizations like UNICEF. So in an October 2020 working paper with the title Encryption, Privacy and Children's Right to Protection from Harm, UNICEF's Office of Research emphasized the importance of including children's privacy rights in policy discussions about child safety. It cautioned states against enacting policies undermining encryption in the name of protecting children, given the vital role that encryption plays in protecting children's privacy, security, and safety. So the current proposal from the Commission fails to strike this appropriate balance. It openly admits that it would violate users' fundamental rights in multiple ways, but fails to reckon with children's inclusion amongst those users. This oversight omits a crucial consideration that must be weighed among the numerous interests that come into play when evaluating whether and how to restrict multiple fundamental rights of individuals in a democratic society in the name of crime prevention. Finally, the proposal is also problematic because it makes unsupported claims about the necessity of detecting grooming via the automated scanning of the contents of interpersonal communications. An intervention the proposal admits is highly intrusive and sensitive. Contrary to the proposal's claims, there is actually peer-reviewed research and scholars like Rihanna Pfefferkorn from Stanford University have demonstrated the prevalence of multiple anti-grooming techniques among online service providers. This research actually supports the viability of other options for abuse detection besides automated content monitoring, such as tools for user reporting. The proposal is currently out for public comment, and I would really encourage everyone who's interested to submit comments to this front. And it doesn't really, it sort of follows much of the proposals that we have seen coming out from jurisdictions like the UK. And whereas the EU had here the opportunity to sort of take a different path, it seems that it's taking the same path as those other jurisdictions. And I will stop here because I believe that there are 5 minutes left. Thank you very much.
Thank you very much, Konstantinos. Does anyone have questions or comments to this? Really? No? I would have expected at least, are you serious?
Yulf, I think Corinne has her hand up.
Oh, yes, you're right. Corinne, go ahead. No. Well, which is interesting because the next speaker would be Corinne anyway, and she just went offline. Then meanwhile, we have a couple of any other business items. So, but if you still, I mean, well, we have Konstantinos here, if you have questions for him. Oh, Corinne is back. No.
Hello, this
Okay.
is Corinne. Can you hear me?
Yes. So Corinne, is the question to this one, or is this your own item?
No, it was the own item. So
Okay. So then we quickly should let Daniel Karenberg actually also was in the queue. Ah, okay. So yes, Corinne, you can go ahead with your part. Thank you. We can't hear you.
Can you hear me now?
Yes, thank you.
Perfectly. Hi, everyone. It's so nice to be able to join the conversation. I had hoped to be in Berlin in person, but that unfortunately didn't work out. Thanks so much to the chairs for giving me a bit of space in the agenda to talk about the Open Technology Fund, where I work as the Vice President of Research. What I essentially wanted to do is just put the fund on everyone's radar, because I think we do a lot of work that's relevant for the REP community. And so the Open Technology Fund is essentially an independent organization that works to protect internet freedom and to keep the internet open and accessible. And we do that essentially by providing grants, financial support for both individuals and organizations who are working to keep the internet open, which naturally includes a lot of people at RIPE. And part of the work that we do is focused on the development of tech. So we support people who want to build VPNs. We support censorship-resistant browsers. We were early supporters of Signal, to give a little bit of an example of the kind of technology that we've worked on in the past. But we also support research and researchers. So some examples of people who have done recent research that was OTF supported. We had one fellow who was looking at the QUIC protocol and figuring out the ways in which it was and it was not resistant to censorship and what kind of could be done to the protocol to improve it. We have another person working on figuring out how ISPs in India and in Pakistan actually end up implementing the filtering mandates that get passed down to them from governments. And we also do a bunch of different projects in and around other countries that tend to heavily limit access to the internet. And as a part of that, we also focus really heavily on supporting the internet measurement community. So we've worked with Censored Planet, with IOTA, with UNI, and also have supported researchers who work with data from the RIPE Atlas. So all of this to say, if this sounds like what you are already working on, then it sounds like it might fit what the Open Technology Fund can support. Please check out our website. We are opentech.fund. And as you can see, if you have an interesting project, you can just fill out a really lightweight application form. And I'm really excited to see what kind of people might pop up. And if you want to have a more in-depth conversation, feel free to shoot me an email at corinne@opentech.fund. So thanks so much for giving me some space. I really appreciate it and look forward to working with all of the folks in the RIPE community.
Thank you, Corinne. So we still have a tiny slot for a few any other items. Jim did, oh, yes, Alex definitely had one, so.
So I would like to remind all the people here that on June 7th, the terrorist content online regulation kicks in, and you will be required to remove content within 1 hour.
Short and concise. Go ahead, Chris.
Thanks, Jill. Chris Buckridge, RpnCC. As you've probably all gathered from presentations today and everything else you're hearing, it's a really busy time for internet governance and regulation. There are a lot of pieces in motion at the moment, a lot of new initiatives coming in. And the RpnCC is engaging in as many of those as we feel we need to, and that's a fair few of them these days. So I wanted to give a very, very quick from the floor update on a couple of things. One is to note that a lot of the work we do is based on working with our community, talking to all of you. And so in that sense, it's probably very useful to you for me to give a quick note about some changes that we've had in the RpnCC team. Some of you would have been very used to having Marco Helgewoning here talking on the RpnCC's behalf. He's actually left us to join the Dutch government as their ITU representative, which is very good for Marco, and we're very happy for him. Somewhat sad for the RpnCC. But so we have some new people coming in. We have Bastiaan Goossens, who you possibly have come across for his work with AMP6 in the past. He'll be stepping into some of the work that Marco is doing. Jelena Kosic is working with us in Southeast Europe to build some more engagement with governments there. And Suzanne Taylor, who I'm sure you all know, is taking a more leading role for the team there, but she's actually off at the CEPT meeting this week. I mentioned there's a lot going on. ITU, obviously there's a lot this year. The WTSA has already happened. There's WTDC, the development conference next month, building up to the plenipotentiary at the end of the year. There's a lot going on there, and happy to talk with community members who might be joining their national delegations or talking to their governments about that. There's a lot going on in the UN level. There's currently an open call for sessions at the IGF, which will take place at the end of the year, but that call ends on 3rd of June. So if you have any interest in doing that, I'm happy to talk more to people about that. I'm actually on that multi-stakeholder advisory group for the IGF this year, so I'm pretty close to a lot of those discussions. There's also in that UN space, a proposal for a global digital compact, which is a new and exciting and somewhat ill-defined document that the UN is hoping to get published next year. And they've currently got an open call for input on that, which is open till September. So I'd encourage people to have a look at that, see if they can maybe provide some input there. And then the final one I just wanted to note is that Eurodig, which is the European IGF, is happening next month in Italy, in Trieste, actually. And yeah, it would be great to see people there, or there in person or online. I think there'll be a lot of discussion as some of the issues we've talked about today, but also some of the other issues that are in the offing. So thank you for the time, Yulf, and thanks everyone.
Thank you, Chris. Anyone else have anything? If not, I notice my screen is now saying Friday morning start. So I think it's time for us to wrap up. Thank you everybody for coming, and it's so nice to see you in person. Thank you.